Oh, I'm sorry. There's a Slack account that we are putting. So if you want to go to this bit.ly link up here, hopefully it should work. Apologies that it didn't work for some of you. Maybe there are limits on the number of people. Or feel free to put your email in here. So those who didn't get the Slack, did you get the instructions though for the GitHub repo and the Azure? Or who has no idea what I'm talking about? Okay, all right, one moment. Okay, so,
Okay, yeah. Okay, good.
So if you guys go to, so there's two things basically. There's the Slack, and then there's also from the front here. Hi. Yep. So we're going to sign in and just
Good.
shouldn't be too.
I'm seeing a fair number of invites
So we're
that
gonna
way.
let me get you the link. So sign up for the Slack, and I have the link in the Slack for. Okay, so it should have given you an. Well, let me press send.
Sweet. We're at 57 members strong in the general panel.
All right. The Inte was already on my team, just so you know you've already signed up. The rest of them I just sent invites to. If you did not get an email about this course, you don't know anything about the notebooks, the best, easiest way is to get an account on Azure. And the instructions for once you're on Azure are in Slack. And there's a whole Azure channel on Slack. If you're having problems joining
Sorry, I keep switching
channels,
back and forth.
let me know. I can show you where they are. I realize not everyone uses Slack.
I was actually going to go through that real quick.
Okay, great.
I can just show that. So if you've never used Slack before, I'll just briefly show you why it's a useful thing and why it's helpful. So when it's running, you'll have something that looks like this. You might only be a member of general or maybe one or two other channels. But there's other channels here. So if you click on this word channels in the upper left corner, you can see the other channels there. And so this Azure channel is the one that Chloe was just talking about. And you can click on it, and it'll say you're previewing this, and you have to hit return to join it. I'm going to go ahead and join it. So now I've joined this other channel, and it appears here on the left under the list of channels that are available. So general channel, everyone is in this one. There's 61 people currently. Azure, there's currently 13 people. There's an I Need Help channel. Linux, Mac OS, Survey, and Windows. There's probably at least one I haven't also looked at. So join the channels that are relevant to you. And I'll show you why it's helpful is because we can paste links in here, like this Azure Notebooks link in Slack, and then everyone sees this link that they can just click on their own laptop rather than having to try to copy it off of the screen. So there's a bit of a bootstrapping problem at the very beginning where if you don't know how to get on Slack, you have to get that link to you. But once you're on Slack, all these link sharing things become much easier, and everyone can share amongst each other. Yeah. Yes, I see that. So I think I might just recommend going with going with this one. So this is just to give an overview of what this Azure thing is. So there's not really a high order of preference, but running the Jupyter server locally on your laptop helps with not making sure that the internet is one of the things that you rely on. Azure is a cloud-based Jupyter server so that you can log into it. All you need is a browser, and now you have the full capability of the Jupyter server at your fingertips. You don't have to worry about installing stuff. So if you're having trouble installing things, please try to do this Azure thing. It should have, I think, pretty much the same functionality that you have at your laptop. It's just hosted at Azure. If you have everything set up and running on your laptop already, you can choose whichever one you prefer. Yeah. Oh. Can you still hear me okay? Like this, okay? All right. I'll just less blowing on. Yes, yes. Yeah, or if you already have one, you can use that. Okay, yeah, so create a new one, and then there'll be a link for just running it through the browser at that point. So fingers crossed, it should be easy after that. 66 people in general. All right. Huh? Yes, there is. Should I snooze it? Yeah. I don't have notifications pop up. They just sit there and have a flag that's just tempting as all hell to click on. I did, yes. That's just so that if it's put in the back seat and it rolls around in a car, it doesn't spill. The mouth is pointed up. 67 people. We're getting up to saturation. Is there a trash can? Actually, okay, I'll just. Should I just talk through Slack a bit more? Do you want to do the intro thing, or what do you want to? How do you want to do this? I'll go first.
Just get an invite now to Slack? Yes, wonderful. Everybody at least have a sign into Azure, if not a GitHub or a Python environment locally installed. We're getting there, we're getting there. Great, great. Okay.
So
everyone's either in the Azure channel or Mac or Windows or Linux for their OS-related questions. Great. Introductions?
Sure, I'll do introductions. Let's do that. So while you guys are finishing up this piece, let's talk a bit about ourselves. So I'll talk about myself. I'll let Chloe talk about herself. My name is Jonathan Whitmore. I'm a senior data scientist at Silicon Valley Data Science. Silicon Valley Data Science is located in Silicon Valley. We do data science, so it's not a creative name, but it is descriptive. We are data science consultants. We've both been there over 2.5 years now, actually. And we work with companies large and small. We're a boutique consulting firm, and we tackle problems at various companies and try to solve their problems with data science. We're thrown into all different kinds of environments, all different technology stacks all the time, and so we just have to hit the ground running and in 3 to 6 months turn around a project that they are impressed with. So it's been a really fun experience, and we've had a lot of exposure to very different types of problems, and we work with a lot of fun colleagues. So today, I'll let Chloe introduce herself, and then we'll talk a bit more.
Well, you introduced SVDS really
That's true.
more than
Okay, so I'll talk about me. I'll
well,
say
you
me.
don't have to. I don't have much more to add to that.
Yeah, that's true. Okay, so me, who am I? I'll just finish my me thing, okay. So, again, I said Jonathan Whitmore. I have a PhD in astrophysics. I did a 3-year postdoc in astrophysics in Melbourne, Australia. And then I did Insight Data Science 2.5 years ago. And then from there, I've been doing data science for Silicon Valley Data Science. So that's my background. Okay, now, pass it to you.
We did the same insight session, so I've known him a long time. Got my PhD before that in environmental engineering, so I've taken a bit of a change. And yeah, excited to be here. We love exploratory data analysis, so we're excited to teach you. We would go through and have introductions right now, but we've already actually gotten through a lot of the time, so would love to talk with all of you offline.
Yeah, sure. I'll just go one more quick overview of the Slack channel because it will be a helpful thing to have your mind around as we work. So on Mac, the keyboard shortcut is Command K to bring up this what do you want to do prompt for you. And I can hit enter right now because general is selected, and I can switch to the general channel, or I can start typing general, and as I type, it will filter the things that are available. So that's just a handy little keyboard shortcut. So it's Command K on the Mac, it's Control K on the Windows, I think. But one of the nice things about Slack is that I can ask a question like, does everyone have Slack to the general channel? And everyone should see this on their own computer. But I can do things like add little emojis, which can let people, let's see here. You can add a reaction by clicking here on the right, as well as doing some other fancy things. I can say thumbs down, and I can say, hey, click on the icon that corresponds to whether you have Slack or not. Exactly. I know it's a bit of a unfair question. So I see a lot of these things, but this, yeah. So you have, if you're still having trouble installing it, it's okay. Good. Yeah, it was a bit of a tongue-in-cheek thing. Oh, I got one person that says they don't have Slack. Oh, that's bad. Canning. And then there's also threading, of course, which is this interface as well. So someone actually replied to the direct comment. But this is useful, I think. It will be useful to share links, to share everything else, to ask questions. If you have an error that comes up while you're typing something and you're not sure if it's maybe Windows specific or Mac specific, or even if it's just a Python error, you can post it in, well, you can post it in general, you can post it in your respective Windows or respective operating system. One last thing that's handy is when you have a block of code, say an error message or something, if you start with this funny triple backtick, it's not the apostrophe, it's the one that's faced the other way. It's usually above, like next to the one, just left of the one. And you can paste in a bunch of code, like I'll just paste this part. Paste this, and 1, 2, 3, and it will do a block code block there, which makes it a little easier to just read when you have like a code block that you have either an error message in or some block of code that you want to share. So I will hope that we will be sharing code in different plots as well. But as we get going, that's what Slack is for, and that's what it's actually pretty handy for. So from there, I think we have next up on our list. Okay, we still have a few more people joining. Bit.ly. I'm going to go ahead and start up a Jupyter Notebook server for my own laptop. I'm in this EDA environment that I created for this tutorial. And when you hit enter on the Jupyter Notebook command, depending on your OS, of course, but you'll get something that looks like this if you switch back to the terminal. So I've written out here Jupyter Notebook, and then there's a whole bunch of things happening. And what's happening here is it's basically starting up a web server, and it's just telling you status updates. It's okay, I'm trying to start this, I don't see any active kernels, a bunch of things. This has to stay open as long as you're trying to use the Jupyter Notebook. And it's just going to be hanging out in a different terminal in the background. And when you run this the first time, it should open up on your default browser something that looks like this, especially if you've changed directory into the Git repo for this tutorial. Once you're here, you see these nice little folder icons, which should let you know that they're directories. And if you click on one of them, you can navigate into that and see the various notebooks that we have for this. So I will say that we have probably too much material here, which means that we probably won't get through everything, but you will have access to the materials. So afterward, if you don't get to it, you consider it bonus material. And so don't stress about trying to get through everything necessarily. There's a lot of stuff here, and we've left a lot of it to be interactive, so we let you explore for a while. This is exploratory data analysis after all, so it should be a fun time. I'm going to have Chloe come up and give an introduction to exploratory data analysis writ large. So I'll start that by clicking on the link. Introduction to exploratory data analysis. You can follow along if you'd like to. And immediately after this, I will be giving a brief introduction of how to navigate and use the Jupyter Notebook, and then we'll dive right into the actual exploratory data analysis itself. So Chloe, go ahead and take it away.
All right. It's magic. My voice just comes on when I want it to. Thank you back there. Cool. If anyone has tips or tricks on how to sign into Slack, maybe you've gotten through a firewall before. There's a couple people who would love that advice. You've got that advice? Oh, you'd love that advice. Oh, no. Okay. Otherwise, you're going to have to become friends with your neighbor, and we'll try to put everything up here. It's just really, we're using the Slack to facilitate questions rather than hopefully relying on it too much. So apologies ahead of time. Okay, so before we get into the nitty-gritty data analysis, I just want to kind of go through some of the reasons why we do exploratory data analysis and kind of set the stage for the things that we'll be thinking about when we're doing that analysis. Okay, so hang on, let's get full screen here. I feel like there's an option to get rid of this thing, but anyway, okay. So, well, as data scientists, we do a lot of modeling. Right now, machine learning is like the biggest thing that everyone's all hearing about, right? You just throw some data into this machine learning model, and it like comes out with the answers to the universe. And people, because of that, it's becoming so easy to do. We're seeing a lot that people just kind of expect to just be able to do that and get what they want. But really, there's this whole step in there, which is the EDA piece, really about understanding your data before you prepare it to put into that machine learning model. And really iterating through that at every kind of cycle through iterating on your model, you really want to understand the data, figure out is that model actually doing what you think it's going to be doing, or you might just want to do it to be able to answer some questions that you have about your business or your research or what have you. So I'm going to go through kind of some of the reasons for EDA, and obviously, because you guys are all here, it means you might see value in it yourselves, but sometimes it's, we found we need to articulate it to people who don't quite understand it either, and we'll get a lot of people going, oh, well, we know, we've already looked at some of those figures. Someone else did some exploratory data analysis already on that data set. Just get to the modeling. And it's like, well, actually, no, you want us to do this EDA for a few reasons. So for us, the data scientists, the analysts, whatever we may be, EDA lets us identify patterns and develop hypotheses to kind of prepare us and give us an idea for what we might want to do to kind of finish out solving the problem at hand. A lot of models rely on a lot of technical assumptions that if you don't actually look at your data and make sure are met, then your model might actually not be valid at all, and you may be working off of poor results. And it will also help you inform which model you want to use and what features you want to put into that model. And then really, the thing that I find is the most important is that you just build this intuition for the data so that when you get into maybe some of the more advanced modeling, you kind of have an idea of what should be happening, of what things to try, that if you just kind of threw all the data in there, you wouldn't have any idea what you were to expect, right? And I don't know about y'all, but I make a lot of mistakes sometimes and bugs, and if I don't know what maybe kind of directionally what should be happening, then I could just give you a completely wrong model and we wouldn't know. But if these reasons don't really resonate with whoever might be consuming the analysis that you're doing, besides ensuring that you're actually providing correct results or valid results, you really actually kind of, through the EDA process, ensure that you're even asking the right question, right? So we've had many clients who will have this question and they'll think that they're asking it for a reason, and really once you start looking at the data, it's completely different, whole different things happening, right? And so there are a lot of business assumptions that can be happening that you want to make sure you're testing before you just kind of blindly answer some question from a stakeholder. And it also kind of provides that necessary context to be able to make sure that the results that you do provide are able to be applied. And we really find that during the EDA process, lots of insights come up that maybe our clients didn't ever even know, that weren't even related to what we were trying to do for them, that actually helped their business a lot. So I was working for one company. They were trying to understand the kind of how people came in for their first visit into an app. And they had made this whole app thinking that, you know, that their audience were these kind of highly expert, enter type of person here, who were trying to get better. But actually there were people who were complete beginners and didn't even know where to start, and they were kind of making the app for basically the wrong group of people. And that wasn't even the question that they were trying to ask in the first place. So just some examples. Some things to keep in mind kind of throughout this whole process, and these are kind of overarching things. We're going to go through potentially some stuff in a very linear manner because we're in a tutorial and that's the way that we have to go. But EDA is not just kind of this thing that you always do at the beginning and then you stop and it's just kind of done, right? It's every time you kind of are iterating through your analysis, you want to go back and make sure that kind of everything is fitting into that intuition you have for the data. Checking results, doing some more plots, making sure you have that full understanding. Another thing is to stay open-minded. So part of the EDA is really try to go in and test all the assumptions you might have. Really think about what those assumptions might be. So for example, what's a good example? Maybe you are having a data set and one of the fields is a date with a time, and you're like, oh yeah, that's the time where they did that action. Let's say it's a clickstream, right? Actually, maybe it was the date that they actually signed in for the first time, right? Or something else. And just kind of really make sure that you kind of test all of those little assumptions that you might make based on someone's poor naming of the column, right? And then lastly, you may do analyses on the same data sets over and over again. But if it's a different problem, you're going to look at it from a different lens. So, you know, always go back and kind of redo that EDA process every time you kind of are going to answer a new question. So, this isn't really presenting worthy, but I guess you all have it. So I have this picture of this tree here because I was trying to kind of visualize how I see EDA. And so, you know, I have these.
I can make it a little bit
Yeah,
bigger.
thank you. He knows all the shortcuts, so if you think there's a shortcut there, he'll know what it is. Thank you.
How's that?
Yeah. So
I can't even turn off this. Keep going.
the way that I think through the EDA process are kind of these 7 steps. And so first, we want to form hypotheses, develop investigation themes to explore. So if you have this kind of overarching question, what are the things that you need to know to actually be able to answer that? What are the things that you need to know to be able to model it, for example? Then we're going to do the fun wrangling of data, which always takes way too much time. And it, yeah, sometimes feels like the job of a data scientist. But we won't spend too much on that here. And then you want to look at the quality of your data and profile it and kind of just understand that or make sure you understand what that data represents, whether there's missing data, if it has any quality issues, before then kind of digging in to understand what information is in the data. And so for that portion, you're going to kind of start, you know, looking at each individual variable or kind of field in the data set, kind of really digging into each one individually. And then you're going to maybe assess the relationship between each of those variables and what I'm calling the target. So the target here is kind of your thing of interest. Maybe you're interested in understanding what makes people churn from your website. Maybe you're interested in what is causing X thing to happen in your lab, right? Whatever that number is, or that field is, you want to look at it now in relationship to all your different other variables in your data set. And then you also want to understand the interactions between all the variables themselves. So, if X increases your target and Y decreases it, but then X and Y change together, you need to kind of understand those relationships too. And then lastly, what I'm calling explore data across many dimensions. There's only so many ways to look at, what am I trying to say? So in those interactions, it's only really easy to maybe look at the interactions of 2 at a time, right? But you might want to understand how do a number of variables interact with each other, and so there are some ways that we can do that as well. So that seems very linear, but it's not, right? So that's why I have this tree is, if you can think of the trunk as kind of the process from going 1 to 7, every time that you do one of these steps, you're going to maybe come up with a question that you want to explore, and you're going to go off and do a whole set of EDA on that, right? And then you're going to come back and then continue going down that road, and you're going to go off tangentially. And so there's going to be lots of kind of paths that you're going to go down to really understand this data set. And then you're going to come back, and I don't have any loops coming back in the tree, but hopefully you get the picture. But because of that, also really capturing the hypotheses and questions that come up along the way as you do this analysis is extremely important, because if you go down one of these branches, you're going to want to remember where all the other branches are too, right?
In command mode, so this blue box, you can type H for help, and you get a list of keyboard shortcuts. It tells you what modifier keys you have. So for Mac, it has these are your Mac modifier keys, which is what I'm running, but if you have Windows or something else, it should give you something helpful there. And it tells you many different keyboard shortcuts, and you can see through the list here. Now, finding them this way is a bit tricky. You can always remember H for help, right? That's an easy one. You can also click help and click on edit, or keyboard shortcuts. So if you really can't remember, that's the way to do it. But there's also, if you're in Chrome at least, Shift-Command-P will bring up this command palette, and you can say toggle toolbar, for example, and you can click on that and it will toggle the toolbar. So that's another fun thing. All right, so let's do the last of the imports, and I will show you a few more keyboard shortcuts. So again, for help, escape to get you in the blue bar, and then type H, so you're not typing H into the cell, and you get the keyboard shortcuts up. And when you're here, you can select multiple cells. This is useful for moving a whole block of cells around, so I'm going to hold down Shift and press it down. And so you can see I've selected many of these cells at once. You can now move these by doing these arrows up and down. You can move them to different places. And you can also, I'll just reselect these things, merge cells together. So by doing Shift, so capital M, so Shift M, merge those cells together into one cell. Very handy thing to do. You can also split cells. It is Control Shift minus. You don't have to know these things. This is just kind of fun things to know, that it's very fast to combine code, move things around, recombine code, split it apart. But again, you can select it by holding Shift and the arrow key. I think you can also do it with the mouse as well. Shift, yeah. If you hold down Shift and click on the next ones, it'll work. I don't think you can do consecutive, non-consecutive ones. No. You can only select in a continuous span. Last thing about the different types of cells here. So as I click on this, you see that it says code in this upper drop-down menu. If I hit down again, just to navigate, you see this switch to markdown. If I hit return to make this into edit mode, you'll see the text that underlies the markdown here. And it automatically gives you a preview of what this will look like when you execute the code. But here's different heading levels. Let's say we want a heading H3 heading, and execute that cell, and you'll see that it fully renders the written part really nicely. So this lets you very smoothly and cleanly interleave text and headings and report generation things with code itself that runs and gives you output. Last little part on the markdown piece, you can monospace the fonts by indenting them by 4 spaces, and I will show you an easy way to do this. One way is by hitting tab if you've selected the whole group of things, and you can do shift tab to unindent. But a more robust way to do this is actually the control bracket or command bracket ones, those square things. So command bracket will indent and dedent as well. So you can grab a whole block of code and easily move it both ways. You can also, if you're in, let's see if will this work? No, it doesn't work here. When you're in a code cell, you can indent a lot of things, or you can comment a lot of things by doing command /. So that's another useful one. Just indenting it gives you something that looks like this, nice monospaced font, but if you give it triple backticks like we do in Slack, and tell it what flavor of language you're looking at, so in this case it's going to be some bash code, then it will do syntax highlighting for that relevant language. So this way you can give code blocks that are readable, that don't run, they're just code blocks there. And so that's very handy. We've already imported NumPy as NP, doesn't hurt to do it twice. But I want to show you a few things here that are really handy. So there's this, let's start with just hitting tab. So tab is your friend. Tab is always your friend. So if you just hit tab, the first thing it does at the end of a line like this, np dot, it gives you a drop-down list of everything that could be auto-completed here. And as you start typing, let's say I type, I know it's lin space, is it line space? Yes, it's this one. I can now, with the arrow keys, select one, for example, hit return, and it fills out the row. That's a handy piece there. Start the parentheses, and now you can hit tab, and the first things it leads with are the keywords in the function itself. That's a little bit unwieldy because it also gives you every other thing that could go in there, which is all these different things. If you do shift tab though, it should give you what's called a tooltip. So now it tells you that linspace is expecting to see a start, a stop, and then these things are optional, num equals 50, endpoint true, or at least they have some default values. And so that's pretty handy. You can also click this plus here to get a longer version of it. Let's scroll down a bit. You can see the full documentation for a function that's readily available. And this is obviously available for NumPy, but it's also available for any function that you write yourself and you execute it and it's in the namespace. That full thing is available there as well. One extra tip about SQL, because we frequently use SQL and we do the polls and pull them into Jupyter Notebook for our day-to-day work, having the history of where that poll came from is very helpful in debugging things. If you get a plot that looks funny, where did you get this from? And you point them to a directory that has 300 SQL scripts in it, it's going to be hard to figure out what happened and what went wrong. But if you actually have it there in the notebook, like this was the query that returned this data frame and then I did this operation on it, makes it much easier for debugging this kind of thing. But with SQL, one hint here, if you do this triple backtick thing, you have to do capital for it to do syntax highlighting. But you can see here, this does syntax highlighting. The SQL version of all caps yelling of the keywords. I'll do 2 more things. There's this thing called cell magic and inline magic. At the end, wherever your cursor is, if you do the shift tab, you can get a tooltip. So I'll do it after one. I'll just do tab, sorry. And you get all the different options that are single and double percent bash, double percent magics. If you have this double percent bash, these 2% ones, this is called a cell magic, which means that everything after this first line is now going to be something special. It's usually not going to be Python code. So for the rest of this cell, it's bash. And so I'm actually writing a full bash script here. It doesn't do anything really that interesting, but it does do a for loop in bash in the bash style. We do a do done loop, and it reads through all the things and do some awk command. And again, this is very useful if you want to drop into doing something. You say, oh, this is actually better for the shell to do it, or I have some command line tools that are way better. You can do one-offs by doing an exclamation mark at the front. You can say ls, and it'll show you that. ls is probably a bad one because you can also do ls without the bang, but you do that bang to start with. You can do any command line option. If you have a longer shell script or something that would be more amenable to a bash script, you just double %bash. And then the last thing I want to do, this is just showing that you can do shift tab on a function that I just created. So I created this silly function, doesn't do much interesting. If you do a question mark at the end, it'll bring up the key signature on the bottom. Do 2 question marks, and it'll bring up the source for that function. So if you're ever doing something, and even if it's a function that you just wrote, like I just wrote this, you can see the source that went into it. So that's a very helpful thing if you're confused as you're going. And you can also do it for NumPy as well. It won't work if it's a ufunc, so sometimes the source doesn't end up there, but this one does actually. You can do C linspace here. Resizable by dragging this bottom thing. And the last thing, well, okay, here's a code commenting everything, command slash or control slash for Windows. Command slash to uncomment things. It's very helpful for doing a whole block of commenting. And again, indenting, dedenting is command bracket left, bracket right. And last thing, if people have been sitting here thinking like, okay, I've seen all this, I know this all, hopefully this one at least blows your mind. I'm going to try to blow your mind here. Fingers crossed. Let's say you had a data frame, or a dictionary, I guess, and you had various things, and you wanted to remove, say, name after the end of each one of these cells. There's a number of ways to do it, but one that I want to highlight here is called multi-cursor magic, where you hold down in Mac it's Option key, Windows it should be Alt. You click that, and your cursor turns into this little plus sign. See? I click it, you see it goes from a cursor to a plus. And this is you hold this down, click and drag, you get one huge cursor. See, it's a giant cursor, All right, so that's pretty cool. I'm not expecting your mind to be blown just yet. The thing that's really cool is you can do word selection to move around. So you can do Option right. And now it goes to one word over for each of the cursors on each of the lines. So you have this broken cursor. It's not just a vertical line. And now I can easily just say, oh, backspace the name there across all of them. And you can obviously do other things like, oh, I want to make these all floats, so I'll put a dot there. So command all the way to the right. So hopefully your mind just got blown there. That was the part that was really cool. What did I type? So I held down the Option key, or the Alt key, and clicked and dragged a vertical line. That's the only way I know of doing it to start it off. I've tried other ways. Okay. Yeah. Really? So Option control? Let's see if that works. Oh, that's even better. Look at that. Okay, I will repeat that because my mind is blown. This is even better. This is excellent. This is why I love doing these things. Okay, so I have way too many cursors now. Do you see that? Like, this is ridiculous. And now you can also hit return and keep going. That's always a fun one. You can escape and you get back to 1. All right, let's undo that. Also, it supports undo, which is nice. Command Z or Control Z. So I was saying before, all I knew to do was you hold down Option and you click and drag, and you get one giant cursor. And then you have to, if you want to do something clever, you have to do something like some keyboard magic to get yourselves to get some kind of broken cursor. I just found out 10 seconds ago that you can also hold down, and for Mac, this is how it works. You hold down Command, and click anywhere else in your heart's desire for another cursor. So I want a cursor over here, and I want one between the 2 E's of 3. Mind blown. And you can type around and do things here. That's very cool. That's even better. Okay, I'm very happy about that. Okay, so that's what multi-cursor magic is. As you can tell, the Jupyter Notebook is a very helpful environment and tool that lets you do lots of cool things. There's many more things that you can do besides this. Let's say I wanted to actually delete that. You can also like escape, type F. I don't know if it works in Firefox, but yeah, I'll keep going. You can find and replace all on the whole notebook by doing things like you just want to replace everything with nothing. Cool. All right, let's get on with the show. So I'm going to start with the red card data set, and this is and Chloe will be mainly driving the aqua data set. We will be trying to cover kind of different things. So we expect to have a whole kind of different angles on the same kind of topic. I will leave it like this for now. So the red card data set came from this article I saw. It's a published article in the top link here. So if you've clicked on that, you should be following along with me here. This #1 red card data set. It's this link here, which you can click on. People wanted the research question they had was, how do different analytical choices that scientists make when they're analyzing a data set impact the final result of an analysis? So to do that, they crowdsourced this across a lot of different teams of researchers. So they solicited volunteers, and they said, okay, we have a really nice data set, and that's the thing we're going to be doing exploratory data analysis on. And the question, everyone got the same exact research question. So the question, as you can tell from the red card name, is about soccer players getting red cards. So the question that they were trying to answer, they gave everyone the same question, was, are soccer referees more likely to give red cards to dark skin-toned players than to light skin-toned players? And so they said, okay, everyone has the same data set and the same research question. What kinds of, as you do this data analysis, the exploratory data analysis, as well as the modeling and everything else, what are the outcomes that come from this? And I just want to give us some high-level view as we're going through this. When you're thinking about a data set like this, it is helpful oftentimes to have a question that you're trying to investigate. So in this case, we have the research question already posed, right? Having that in mind is very helpful to say, we're trying to get to the bottom of something like this. And you can always pivot, or you can change, or something from the data will tell you something new, but it is helpful to at least start along this path. Another handy thing is to draw a plot that you want on a piece of paper. So if you have a thing next to you, like just a notebook, and the thing I want to see is this variable versus that, and I want it to see if it looks like this or looks like that. Just even like a brief sketch to get your mind thinking in a visual way about the data set. That's a very helpful thing to do. Also, as often as possible, write down what you are hoping to see or the question you're trying to get to the bottom of as you go along, so that you have some direction for yourself, and you can look at what you did later on, but you also can share your analysis with someone else. And always just keep in mind these questions about how do you know you're not fooling yourself? What else can you check if it's actually true? If I found something that's interesting, what evidence would show that this is a wrong conclusion? Those kinds of questions are always good to have top of mind. The first thing we're going to do is we have to run this cell to load in some libraries, and we'll actually go into the data itself a bit more. So here's what the write-up was for the data. There's 146,028 dyads of players and referees, and includes details from players, details from referees, and details regarding the interactions of player-referees. Okay, first of all, what's a dyad, right? That's a word that's probably not super common. It just means an interaction. So it's when referee A was refereeing a game that involved player B, then that had a line on the data set. And they had 2,000 soccer players across 4 divisions in Europe, the divisions of England, Germany, France, in this season of 2012 to 2013 season. And they have all referees, which I have 3,000 referees playing here. It turns out that it takes a little bit more digging, but this is the player's entire career. So if they have been playing since 1995, and this is as of 2012, what team are they currently playing for? How many red cards have they had in their entire career up to that point as well? So it's not just that one season. But here is a variable description, so like a data dictionary for the data that comes in this data set fully formed. So you have the short name of the variable name on the left, and the description that they gave on the right. load in this data. If you have it on your local laptop, you'll want to uncomment out this line here. Again, / to uncomment. And this will load in a data frame that is the red card CSV. If you are using the Azure notebooks, you have to undo the lower, uncomment the lower one and run that cell. You only need to do one of them, basically. Pick whatever one works. If one doesn't work, then try the other one, because it doesn't hurt, I guess. But you only need to do one. But now I've loaded in with pandas, which is alias as PD, this data frame. There's a lot of things we can do with pandas, and you'll see a lot of the functionality here, but the first thing you can do is just take a look at the shape of the data. And by running that cell, you get the output from that says there's 146,028 rows by 28 columns. And if you want to look at just the first couple rows, df.head shows you a truncated version of that data set. So you have the short version of their player's name, a longer version of the player's name, the club that they're playing for, the league country, their birth date, height, weight, and so on, all the way across. And you can tell that there's actually some columns missing here that were just truncated because it's saying, okay, this is really a wide data set. Pandas comes with a number of fun, high-level things you can easily do. Just describe. If you do describe, it does it in a long way, the same width as the head. But if you do .t, it will give you some of the high-level statistics just to give you a quick overview. So the height, the count is this many, the mean is that, the standard deviation is so on, the percentiles, the maximum value for each of these things. And it's smart in that if you see, there's a photo id.jpg, so it's like some file name that got in there, it knows that that's not a numeric column, so it doesn't try to do anything fancy with that. So it's pretty smart in handling those things. It handles nans pretty well as well. You also do D types just to see how it got loaded in. You can tell the object is basically a string in this case. So the player's short name is an object type. Their height is a number, a float number. The yellow cards, how many yellow cards, how many red cards they got. This is an integer. So these all look like they got loaded in a reasonable format at least. And you can grab what are all the columns. Basically, I want all the columns of this into a list. You can do this to df.columns, and I'll show you this. Is fun to use the tab complete as often as possible. You start typing columns, hit tab, and it finishes the word for you. And then we want to do this to a list. You can hit 2 and hit tab and see the options. And we want it to turn this into a list. And you can see that you get this list of columns here. This will be useful for a decision point in just a couple more cells. So I kind of tickled your fancy by telling you that there was a number of teams all looking at this data set, right? I won't tell you, well, I will tell you what they've done. So this is from the paper. Along the x-axis, along the top, is the research group number. So just, there's 32 groups that signed up for it. I think 29 ended up actually submitting their results. So basically 30 research groups. And the Y column is the variables that they chose to help answer this question. And they get a black bar, or a black cell, if that group chose that covariate is what they're calling it. So in this case, did you use the player's position in this thing? And they have a black bar there. And it's very interesting to see that, as you'd expect, the choices that they made, well, actually, I wouldn't have expected it to be this diverse. Basically, there wasn't a covariate besides skin tone, which had to be there, that was used by all of them. The one that was used most was position, and 62% of the teams chose it as a thing to include in their analysis. And it just goes down from there. And no two teams chose the same covariates. And so that's an interesting thing. So there's obviously many ways that people have sliced and diced this data set to look at it. It's very rich in that way. So you could, okay, the question to be repeated is, why did some of the teams choose 0 covariates? Okay, there's 2 possible answers here, and I suspect these 2 didn't return it. The other one is that they decided they could just not use any covariates and just, I don't know, yeah, I guess you could just throw something at it, but my guess is, because I think it was 30 in the end, so I think there was 2 that didn't return it, or 3. I think 5, 7, and 8 probably didn't return it, yeah. The which are? photos. Yes, you can't actually use the photos because they weren't given. That's just the name of the photo ID. So like here's the thing. It's like this photo ID is just some string, which is like photo642.jpg, but you weren't ever given that photo. You were given the skin tone rating from 2 different people. I think these are the ones that were chosen because it included all the ones that had 3%. So I think even if only one group chose it, they included it here. So that's just choice in which variables you used in terms of what goes into the model. These are the different choices they made within what different types of models could you use to answer this question, including the odds ratio of the effect that they found in the end. So they have 0 inflated Poisson regression was team 12. Weighted least squares regression with clustered standard errors. I mean, all kinds of different things. So very many different approaches to this as well. The final results were really interesting and written up on 538, the blog. So no teams found a negative effect, that it was the opposite. It was are dark skin tone players more likely to get a red card? No one found that they were less likely. 9 teams found no significant relationship, and then 20 teams found a positive effect. With this is the varying thing. So equally likely is this horizontal bar here. And I chose the 538 visualization because I think it's better than the one they did in the paper. But the error bar around the effect size. And so you can see even here you have like a significant result where the error bar is smaller than the data point here. And one's over here where the effect size is large and the error bar is enormous. So these are their different teams' estimation of the same research question with the same data. So there's a pretty sobering thing here, which is just like, if you selected randomly from the present teams, which are researchers, there would be a basically 69% probability of reporting a positive result and a 31% probability of reporting a null effect, which raises the possibility that many research projects contain hidden uncertainty due to the wide range of analytic choices available. Their conclusion from their paper. So this is a very interesting, fantastic thing. Yes? Please. No, yeah. Can we turn on Chloe's microphone real quick? Okay.
Sorry, thank you. Just want to quickly interject, because not everyone's just looking at Slack all the time like I'm used to doing. If you are having problems with HDB scan, just comment it out for now. Apparently it's not working on Macs. And then if you are on Azure and you're having just a lot of modules not happening, look at the Azure channel on Slack or raise your hand and I will help you get those installed. There's just a few that we have to do manually on Azure. The big list is on the general channel and also cross-posted in Azure. Also, this is the wonderful Stuart who, in our rush to get everyone ready, I forgot to introduce, and I apologize, but he has volunteered to be helping with all your Python-related questions. So he'll be walking around as well as one of us during the tutorial. So feel free to grab one of us. Is this a question for the audience, or do you want us to come around? Okay, great. Anything else that I'm missing, or just general tutorial level questions? Just wanted to get them out of the way. Awesome, thank you.
So anyway, I thought this is, back to, hopefully I'm being microphoned. So anyway, this data set from that result alone was something I think is very interesting to look at and try to just decide that stuff for ourselves. So the challenge I give you all is to before you look below, try to answer some high-level questions about this data set that you just loaded in, that they gave everyone else as well. And think about how you'd operationalize the question of whether referees are giving more red cards to dark skin tone players. So you can think about the counterfactual. If the player were lighter, would the referee more likely to give a yellow card or no card for the same offense? Or you can do regression. Think about how you want to do that. Even before you start, well, there's 2 different raters. So the skin tone rating was given by 2 people, raters 1 and rater 2, who rated them on a scale of 1 to 5, I think. And what do they What if they disagree? You know, these kinds of questions, something you can write down at the beginning, like what's your plan for if you come across these different situations in the data itself? And yeah, I'll give you guys, you can read over those questions and kind of understand at least the thrust of the questions I'd like you to be thinking about before you even dive into this data set, to get yourself centered in how you're going to think about how you would answer the question. And I think we can keep going with this. We have the data frame loaded. There's a potential gotcha here, which I intend to illustrate with this next example. So it was given in this format where every player and referee pair had a single row. So if that happened for a single game, I got a single row in that data set. If the same referee refereed the same player for 10 times, it still had a single row, and it just aggregated everything across that row. What that means is if you try to do the average height across the data frame to get a sense of what's the average player, you could do this height.mean. Another way of doing that is df height.mean to access that column name. But that tells you the average height listed for every row. It's not the average height listed for each player. The way to do that, there's a couple ways of doing it, but you can do a group by. So I want to group all the different players together. So if you saw the player listed 10 times in a data set because he had 10 different referees, don't take his height 10 times and then the next person who had a different referee 10 times, but just that same referee once. So you collapse them all by 1, and you can see that there is a difference in the height in the values here. Yeah, question? No, it's from, so the question is that you can only get 1 red card per game. Very true. Red card is an ejection from the game. Yes, it is your entire career. So how many red cards did you get over your entire career up to the 2012, 2013 thing? So if that's your only, if you only played 1 game in that thing and you got a red card, you have a 1. You didn't get a red card, you have a 0 red card, 1 game. If you have 300 games that you've played in your career, you have 300, maybe 20 red cards. Shows up, well, for that referee. There is, but you have to dissociate. So this is the kind of the problem I'm trying to elucidate here, is that the way it's organized, to answer even simple questions like what's the average player height, you have to actually think about this step before you even do it. Like, oh, I have to make sure that to disaggregate the players into 1 player per height value and then average that. So just doing a simple average over this, risks double counting, and you get the wrong answer here by, okay, admittedly by a small amount. But one way to get around this difficulty is to use this concept of tidy data. There's other names for it as well, but Hadley Wickham has a very nice paper in this PDF here which talks about how if you organize your data set so that each variable forms a column, each observation forms its own row, and each type of observational unit forms its own table, then it allows for exploring the data in a much, much nicer way, and it allows for tools to do their own aggregations later on. So for the first step, I'm just going to tell you what I think a tidy version of this data set will look like. First, there'll be a players, we don't need to execute that. There'll be a players table. So I need a table that has a unique ID per player and all of the physical attributes about them and what they're doing. So their height, their weight. Let's just go through and look at what that looks like here. So these are the columns from that original data set, that 1 data frame we started with. We'll take their birthday, that's unique to each player, their height, their weight, the position they play, and these as well, the photo ID and their skin tone rating as rated by rater number 1 and rater number 2. I'm calling these the player columns, and the player index, the thing that I think will be keyed on in other tables, is the player short, which is the short version of the name. Now we can say, there's a number of ways to grab this together. So we take the data frame and do a group by object, grouping by the player short. So this is the way we get the column ID, and do an aggregation here. So we want to say n unique is the number of unique values in this table. So we will do for each column in the player columns up here, give us the number of unique plays and store that in this thing called all columns unique players. And just do a head here. The sanity check that's happening in this quick bit of code is that if a player, say Aaron Hughes, had a birth date written down with one referee interaction and had a different birth date written down in a different referee, then this would have a 2 here. In this birthday for Aaron Hughes. Right? This is counting up the number of unique values when you collapse all the rows together. And you can check to see that they are all, in fact, less than 1, which is, you have an empty data frame here. So, okay, good. For every player, they all have 1 value here as well. So we can, you can test whether it's unique by doing any number of ways. You can say, are these players having unique values for each of these variables? And so we got a true value there, which is good. We say, hooray, the data passed that first sanity check. And all I'm going to do here is create a function that does what I just did above for each of the tables we'll do below. So it's called get subgroup. So it takes the data frame, takes the index for the group and the columns for that group, and it returns a group by version of the data frame. And it does just a warning check, basically, to make sure that they all have unique values. So we can do that by saying, okay, we're going to set the players table to be get subgroup, and I executed that so you can see that I have the tooltip here, and I can get, oh yeah, this is the 3 things that need to go into this. I'm giving it the player index, which we defined above, the player columns, and the players table now, data frame, looks like this. Shift tab while you're inside of the parentheses. Yep. Cool. So that's the players table. We also would like to save this group out for future use. So let's create something that I'm going to create this up in the directory above called raw, and this is the raw table because all I've done is do a single group by, grab all the rows that are in that player column, and then let's save that out. And then it does a test to make sure that if we load that back in, do we get the same thing we wrote out? And that's just what's happening here. If that's not clear, you can look at it at your leisure later on, what's happening there. Okay, so now we can do the same thing for the clubs. So there's different clubs that are being represented in this data set. And of course, it's now much easier because we set up some functions above, and we can say, oh, clubs is get subgroup data frame. That's the data frame we loaded everything in. The club index is this club name, and the columns is actually just this one thing. Which country are they in? And this is the entire, this is not the entire thing. This is the different clubs and which league country they're associated with. This is another observational type. For each club, there's one country, and that's all the things that get sorted there. There are only 4 country types, as they said in the data dictionary. Good to double check. There's 48 clubs in England, and so on for the rest of them. We can save that out so we have the raw table written out to the raw clubs CSV. All right, let's do the same thing for creating a tidy referee table. So this is a very quick one, the referee number and the referee country. Although this starts to look suspicious because the number increases monotonically with referee country. So let's actually check that there's, let's do some sanity check here. What's the total shape of the referees table? Okay, good. There's 3,000 as we expect. 3,000 referees and 161 unique countries. So that's not doing something crazy. Yes? I don't know. I don't, it clearly, okay, the question was, what happens if the referee changes country? Thank you for that. Yeah, no, it's good. It's good to repeat it. That is the thing we tested for, to see if they actually had the same referee have 2 different countries, and they didn't. So that either never came up, or they resolved it by saying whatever the last one was the country that they're from. Same thing with the players' team that they're playing for. If they played for 3 different teams in their career, you only get the club that they're with on 2012, 2013 on that year. So you only get 1 value for that. That was part of the checks in this, like how many values am I getting for each of these players? Well, it's conceivable they could have multiple. They only got 1. So a thing to note in the EDA, well, I have a question here, and I would encourage you to write that down at that stage. A good question to have, and a thing that other people looking at this analysis later on should be aware of. Another question, yeah. Mm-hmm. Absolutely. The question, again, was there could be a particular bias of a referee against a particular team, maybe a team from a particular country, for example. And if the player plays for different teams across different countries, for example, then they could have, for the same referee, a differential bias from the referee. Yeah, there's lots of these things. I think it's partly why it's such a hard data set to get their head around and actually get an answer that everyone kind of agrees with. Yes? Sure. Yeah. So the question is, you have a UTF one. I don't have a suggestion for that one. Are you running Windows? Yeah. Okay. Okay. Yeah. Good to reference that. So you might have to then. So okay, there's other notebooks that you load in this data. This is why we did this test here. So write out the raw data form and load it back in. If you can't do this, write it out to CSV because you have a UTF error, for example. You'll have to reproduce this code in a different notebook. So you'll have to just like grab it from the same data frame. As you can see, it's not that much code, right? It's like 4 lines, which is unfortunate, but why we'd like to. They said there's UTF error. If you chat with him, maybe he can tell you how it goes. That's just a guess from mine. So worst case scenario, though, you can just rerun this same code and grab it out as a separate one. All right, let's just, I think we have a sense of what's happening here. So let's create the countries table. Rename, I'm going to do something here. The countries table has this thing called alpha3, and then there's the implicit association test score. This is about scores for different countries and how implicitly racist or biased they are as a country, and then whether they're explicitly as this other one. But this alpha3 is not a very helpful column name, so I renamed that column to be country name. And so then it looks like this. So it says country name instead of this alpha3. So that's the rename command. There's 161 countries. Let's save the subgroup. Oh yeah, and then I get a warning here from this one saying the equivalence didn't work. And I go through a test here to figure out what is going wrong. And so I read in the same file I just wrote out, this raw countries.csv, and try to figure out where they don't agree. So if not row 1 equals row 2 when I zip together these things. And these 2 rows apparently don't agree. I try to find out what the difference was here. And so then I save this out, and row 1 doesn't equal row 2 at this exact value, SEIAT, which is this long precision float here. And the difference in it is basically a precision error. It's 10 to the minus 19. So I'm going to call that probably not a problem, and that the test data frame, which is the one I read in from the file, and the one I wrote out are the same because the head looks the same, the tails look the same, and the only error seems to be a rounding error. So that was like a thing that happens in the wild as you're going through, like you get some error or some warning up, and like, is there a sanity test or sanity checks you can do to see is there a way around this? All right, let's keep this dyads table for a little bit later because it's going to be a bit more complicated, but the index for this is going to be what's called a multi-index, meaning that the referee number and the short name of the player is going to be what we're indexing on, and then the columns for the dyads will be these remaining columns here. So this is what it looks like. So referee number 1 was paired with Lucas Wilches, and for only 1 game. So referee 1 only appeared once in the entire data set, and only refereed 1 player 1 time. Then you have someone like referee 3 who has at least, let's actually see if we can see if there's more than that. So referee 3 had at least 3 people he refereed. These 3 people, each one for 1 game. And you can see how this is organized, where the referee that's shared amongst multiple people is collapsed in this way. It's nice to read. And so the shape of this table is 146,000 long by 8. And just to take a look at some red card counts. This is what the referee numbers with the different red cards are. So I'm selecting the dyads table that we just created by the red cards greater than 1. And let's finally save this out as a group. It's a little bit bigger, so it'll take a second. And the test passed, we recovered the equivalent one. So we've at the end of this first notebook, we've taken this big data set, and the first step of this is to take a look at the data, make sure it doesn't have anything crazy. Make sure that you don't have repeated values where you don't expect them, or if you expect repeated values, to make note of am I only finding each player only plays for one team if they have a 12-year career, that's noted and available for someone else to look at this data set later on. So I will now go to the second notebook. So red card 2. So the top is just a reposting and a re-importing of libraries that we need. A tidy data reference, and again the save and load functions from the previous file. So now we can just say, let's take the players table and let's make sure we got it back same as we hoped for. So we're now running in a new notebook, meaning we just started a new kernel and nothing we had from before was saved, so we had to load in everything new. And by input number 4, we already have the players table all set up. All right, so this allows you to do coming back in and do future stuff much faster, just to have everything loaded up, and you've named it in a way that hopefully makes sense to everyone else. So let's take a look, let's do a deep dive on this players table and try to figure out what's going on, if there are any problems with the data itself. So the first thing we did was just very, very rough cut of this. So this missing no is a very nice package if you get it to work. It is a visualization of the missingness of the data. What does that mean? So I took the players data frame and I sampled 500 rows from it just to give us something that was reasonable to look at, and gave it some figure formats as well. But you see every player in the 500 had a birthday, and you had photo ID, rater 1, rater 2, their position, by height and weight as well. So the white bars, the parts where it looks more like a barcode, is where there's missing data. And visualizing it like this lets you see how correlated it is. So these 3 rows in particular look to be fairly correlated just by eye, and you get a sense of how much it's missing. So the bar chart on missing numbers, the thing will tell you it adds up the same. It stacks them. So instead of having the white space interleaved by row, it's now collapsed this way. And so we actually find that photo ID, rater 1 and rater 2 are, there's a substantial fraction of data that's missing. And what's interesting about that, the thing that should cause you pause, is that the thing we're trying to figure out is, are dark skin tone players more likely to get a card from a referee, a red card from a referee? But if we don't have a value for their skin tone from either rater, then that can't actually be in the data set, right? You can't predict just Bob or something, right? Like whether this person will have a bias against them from not having that. So let's do a heat map of how correlated the missingness is. So this is the missing numbers thing dot heat map. So it says how correlated is the missing data. So you see what down here, the photo ID, rater 1 and rater 2 data are 100% correlated with each other. So the missing data there is incredibly correlated, which is good news. And we can do a couple tests here. So what this is testing is, okay, give me the length of the entire players table. That's 2,053 players. Give me the length where every single row, where every player rater 1 value is a null value. That's 463 values. Give me every row where rater 2 is value. Give me a count of those. 468 of those as well. I can't read it. And give me a count of where they are at the same time both null with this last one. And it's the same exact number, which is good news in that, okay, we have, it's not just missing that if we had a rater 1, we didn't have rater 2. If we have one, we have the other one. If we don't have one, we don't have the other one. So let's take it, we can just do it where rater 1 is not null. And so we get 1,585 players. That means we've dropped 468 rows from the players table, and there's 1,585 to go. So I've just added a note here. We've removed 468 players from the table who had no skin tone rating at all. So now let's take a look at the missing data again. So we'll take the same exact code above, but now at the modified player table. And now we see the birthday, I guess, fully populated, and so does the photo ID and rater 1, 2. And the bars look similarly happy and encouraging. Now, we have 2 different ratings for each player, which leads to the question, are the ratings similar enough, or are they different, or is there some extra information there? So we'll do a correlation between rater 1 and rater 2. Let me zoom out a little bit. So this is correlating rater 1 and rater 2. And you see that 424 people both got rated 0 by rater 1 and rater 2. And the diagonal is where they agree, and the off diagonal is where there's disagreement. And you can see that there's actually no one that's 2 blocks away. Everyone's within 1 rater view of this. So for me, this is a pretty good indication that they largely agree. There's ways you can do this statistically in a statistically valid way if you really are curious about this, but I think that this is, I'll call this correlated enough for me. So I'm going to give a new column. This is definitely a step in the EDA thing. So I want a new column that's going to be useful for me. I'll just call it this actual skin tone. And the way to create a new column in a pandas data frame is by doing this skin, you just call it, say, player's skin tone, which doesn't currently exist, equals, I'll do the average of rater 1 and rater 2 values. And you see here a heading value of it. Let me zoom in a little bit again. So Aaron Hughes, rater 1 gave a skin tone value of 0.25, and rater 2 gave a value of 0, so the average skin tone is 0.125. Any questions about what I've done so far? Okay. So let's take a look at the distribution of this univariate, meaning just one feature thing. This is enormous. So here's the counts of the players versus the skin tone rating. And you can tell that there's a lot of ratings below, say, 0.3, and then kind of an even keel across the rest of them. Now, there's all kinds of other questions you can do. So you've just taken a look at this, and at this point, you can decide. You can make some decisions, or you can decide whether this makes sense, whether this is surprising, or further questions that you have. Write them down at this stage and say, like, I want to now look into this thing or that thing. Another column that the players table has is positions, what position that they play. And just naively, do you think a player's position would correlate with the susceptibility to getting a red card? Just to me at least, it seems likely that a defender would have more likely to be a red card than a goalkeeper, for example, which doesn't actually have many interactions. So let's take a look at just first of all the different counts of the positions as we see them in the database. And we see there's actually quite a few positions here. Now at this stage, what I did, this is the thing where you can definitely disagree with me. You just have to, if you were to do your own analysis, and the only thing I would require, I guess, is that you just kind of roughly sketched what your reasoning was for this. But for me, I said I would like to collapse these things. I don't know. I could be very wrong on this. I would be open to, this is like a question I'd have open to go back and check later if I thought it might matter. But left versus right fullback, I suspect they have similar, say, risk profiles for red cards. Same with the wings, right and left wing versus, say, the midfielders. So I'm going to do this, create a high-level category for these positions. So I'm going to create a new column. I'm not going to overwrite the column that already exists with the positions one in case I need to recover. If I need to go back and find this out, I don't want to have blown away that extra column. So I'm going to create a new column, and I'm going to call it position types. And the way I'm going to do that is just take a look at what they are. This is the position types. I'm going to create a thing called position aggregated. So position underscore ag. And I'm going to say these positions are defensive, largely. So center back, defensive midfielder, left fullback, right fullback. So I'm going to call those positions largely defense. Midfield are going to be the right midfield, center midfield, and left midfielder. So, okay, those are the midfielders. The forwards are attacking midfielder, left wing, right wing, and center forward. And of course, keeper is just the one thing. It's just the person who's a goalkeeper. There's only one of those. So with those, I can now take a look at what the positions are and aggregate that. So here's the counts of the different types aggregated by my situation above. And again, I'm not saying that this is necessarily the best way to do it, the only way to do it. If someone wants to argue with me and say that actually there's a huge difference between right and left fullback. It's like right and left field in baseball. One's one where everyone hits everything, and I'm fully open to that argument. Please choose your own separation there. I could be doing this completely out of ignorance, but I did something to the data, and I also explained what I was doing and why I thought this made sense. And that's at least a very good step to start with this kind of thing. So here's what the distribution looks like of players. And there's also a fair number of nans. We don't have their actual positions. So that's an interesting, not that many. I mean, it's 150 out of 1,500, but it's not completely negligible either. Let's just take a look at height and weight, the variables, because it could be conceivable to take a look at how, say if someone's a very tall and very heavy player, they might more easily either draw red cards or give red cards. I could see that being some kind of systematic difference between these kinds of players. So I think keeping height and weight variables around is probably worth doing. An easy way to check now, we just did a bunch of univariate things, so just looking at one dimensional on this players table. You can also look at pairwise things. So how do the two things correlate without even looking at the target variable, which is red cards? How do they look? So Pandas has a nice function called scatter matrix, which lets you give it a data frame, and it will create all of the what's it called here? The cross terms. And so height versus weight gives you this. There is a clear trend between height and weight of soccer players. And on the diagonal, you give it this thing here. So I said on the diagonal, give me a histogram. So I'm not going to do height versus height, because that would just be a one-to-one line every single time. So instead of giving me one-to-one line, give me a distribution of what that variable looks like. So if you want to take a snapshot and look at a single data frame and all the different numeric column types that can be compared with each other, you can just do a one-shot, give me a scatter matrix of this, and it does that to let you quickly, by eye, see relationships that you might not have otherwise plotted. And so if you want to pull out one relationship in particular, say you want to look at height versus weight, there's ways of drilling down and just looking at that specifically as well. So as you are going through this, so you have about 10 more minutes before I let you guys go for a break. You can share this easily if you have, let's say you get this plot here and you want to share it with everyone. You can right-click on it and say copy image, and go over to Slack. Okay, gotta do this. General. I can just paste it here and say cool distribution. And I should upload this, and you guys should all see this in the general channel. Well, shortly, as soon as it's done. I'm thinking about it. Yeah, I did that. I said there was no windows. Let's see what's going on here. You see Slack as well. Sublime text. Okay. Let me just blow that away, I guess. Weird. So here's the fun thing. If you lose your browser in the middle of doing an EDA analysis, you can usually get it back in your current state. Where is this guy now? Minimized? Okay. By going to, say, this guy. Cross your fingers, see what's running. Sure enough, this thing's running. And let's see, what is the last time I saved it? I saved pretty compulsively, so yeah, okay. And here's the nice thing. It's still connected to the same kernel in the back end, so it's just now the 28th command there, and I just got it back. So if that ever happens to you, yeah, it does checkpoints for you automatically as well, but I might have lost 3 cells or something. But this also, so if you, there's restarting the kernel, which is this thing, and you can also refresh the browser, which gives you the, or you can quit the browser and go back in and still have it running in the background. So that's a kind of a funny side note. So a couple other things I'd like to show real fast is if you have a continuous variable and you're doing some kind of regression, so weight and height, using the continuous variable is fine a lot of times. But if you want to do some visualization of is there a relationship between things, sometimes it's easier to actually make categorical versions of a continuous variable. And there's lots of ways to do that. You can look at the distribution and decide the points yourself. Say anything less than this has been 1, anything more than this has been 2. But Pandas has a nice way of doing it with this Q cut, which is a quantile cut. And let's make it big again. What that does is it takes the full continuous spectrum and cuts it into bins, and you can tell it either the breakpoints you want explicitly or just the percentile bins, like I want 5 bins. So in this case, I told it I want the length of the number of weight categories I had, so I had 5 weight categories. And I did the same thing for height. And I can do 3 a quantile cut for cut into 3 for the skin tone players. And the last thing I want to show before I do the challenge is this thing called Pandas profiling. And I'm showing it near the end here because it's trying to do this whole thing for you in an automated way. And it's tempting to look at that first. I would recommend not looking at it first because while it's very helpful, it tells you things like this. Oh, so birthday has high cardinality. There's a lot of distinct values. Okay, that's fair. Position has missing values. Positioning I has this many missing values. Radar 2 is highly correlated with Radar 1. And you get some high-level sketches of what's happening in the data. So you can see, oh, here's what height looks like. And you can actually see more details by clicking the toggle details, and it'll show you, some various other things here. Very handy stuff. And it tries to be smart about things too, which can get you into trouble. So it's like photo ID. But as you scroll down here, for example, it says Radar 1 is a numeric value, and you have all these different values. So this is the skin tone values as given by Radar 1. But it says, you don't need Radar 2 or skin tone because they're highly correlated with Radar 1. And if you were just to blindly accept this suggestion, you would be taking the wrong one that you should take. Obviously, you should take the skin tone one. That's the one that's the average of the 2. And obviously, they are very correlated with the other 2 correlations. But so what you really want is skin tone, not the other 2. So it's good to look at, but it's good to do after you've, I think, soaked yourself in the data for a little while to figure out what's happening and where. And then it'll give you a sample of it as well. And I guess the final question about what to do with this birthday column. I went back and forth on this on myself and decided to open it up for you guys to decide what to do as well for yourself. Because it's the full player's career red cards up until 2012. A person who's, say, 19 and doing their first year playing professional soccer has only had 1 year possible. And then how old are they? They're 19. A person who's 30 and had a lot of red cards maybe earlier on and then mellowed out a bit, let's say, as a player. You just get their whole career as one snapshot and that they're currently 32, let's say. So it's a difficult question, and I don't think that there's necessarily a right answer to this. But I decided to show this briefly because dealing with timestamps is a pain always. And this is how they wrote the birthdays in this day.month.year format. And I always want to show you how one way of grabbing this and changing this from birth date into a variable that's much easier to use. So I'm going to create a new column called birth date. I'm going to do this toDateTime function out of pandas to take the birth date, and I'm telling it the format. I'm like, look, this is a crazy format. It's not anything standard at all. It's this %d, %m, %y thing. And I'm going to take the age. I don't really care about their birth date. I want to know how old they are. And I'm going to take everyone from January 1, 2013, because that's the midpoint of the season from 2012, 2013. And I'm going to divide, because I'm going to get days. This is a DT, is date time functionality in pandas, and take days, which tells you how many days between those two dates, and divide by the number of days in a year to give me the year. So this is what the distribution of ages look like after that series of transformations. And if you've never done anything with date times in pandas before, I would be willing to bet going from this to this would take you at least half an hour. It's kind of, it's madness at times, how unfriendly it can be. What? Stay away from date times? Yeah. It's a good recommendation. But I thought it was useful to put in there because it can take a huge amount of time. So here's now what our player's data frame looks like. It has all these extra columns that we created, bunch of things including birth date and years, as well as birth day. So let's take a look at the columns that we currently have. And what I usually do is I take this, I'll copy the output from the columns, and I'll put this into a new one, and I say, I want these are the clean variables. These are the ones I actually want to use for my analysis. And it'll be these ones I comment out, the ones that I think, I don't need the photo ID. I don't need radar 1, radar 2, I have skin tone. I don't need the birth day, I have their age and years. I've made these kinds of decisions, and I make them explicitly, because I say, here's all of the columns, and here's the ones I'm commenting out and not wanting, right? So someone else can later on look at this and say, oh, okay. Or disagree with me, say, what? Why don't you have position in there? And I can say, I did position aggregation, that's why. Oh, okay, that makes sense, right? We can have a disagreement about it. Now we can do the profile report on the clean variables, and we get this same kind of overview snapshot. Let's write this out, instead of calling it raw now, because we've done a lot of transformations, we write it out same spot, but now it's cleaned players. And the challenge for you, so it's now 10:50, right on time for a 10-minute break. But do this same kind of thing. So I went through pretty explicitly here with lots of code on how to do this on a pretty involved players table. Do it for for referees, clubs, and the country data frames. They're much smaller, a little bit easier. You can do that on your own. And there's the other notebooks will also walk through some of the stuff I did with the dyad table, which was a much bigger headache for that. So any questions before we go for a break? Yes, so this is for the players table. I wanted to say, the challenge is to say, we did a lot of things to clean it up, right? We changed the birth date to an age that made sense. We combined the positions in their very granular form into a higher level one. So do those kinds of decisions and thought processes through each one of those tables that we made in the previous notebook where we did this, like, here's the full data frame. Just grab the players, put that into a players table. Here's all the referees, put that into the referees table. Here's all the clubs, put that into the clubs one. So now go into each of the other ones and try to do that on your own. I don't actually do that because they're all much easier than the players one. And then I think the next one I have here is the dyads one, right? Yeah. So the red cards 3 is the much harder table than players even is the dyads one. And from there, that'll take you quite a bit farther. And then the last one, red card 4, is the final joins. And it starts to do correlations between skin tone and prevalence of red card rating, holding constant the position type, that kind of thing. So complicated things there. Any other questions? So let's take a 10-minute break. And when we come back, we'll actually switch data sets. And Chloe will be walking us through the Aqua data set. And feel free to work on this in the break and ask me questions as you come up with it. And I'll meet you back here at 11:02. Thanks, guys.
So I'm going to have a little bit of a preamble. If you're using Azure, please listen to me now. I'm relying on as we go through these next set of notebooks, I'm going to kind of functionalize things that we're doing quite a bit. So like plotting a histogram, let's not write 5 lines of code every time. And then as I go, I'm putting those functions into a helper file, which in the GitHub repo is under scripts. But with Azure, we actually need to go and load those manually right now really quick, okay? So I put in the Azure Slack channel, and they're also in the GitHub repo, aquahelper.py, and also a JSON called world.json. So if you are using Azure, please go to the Data tab in the Aquastat Introduction Notebook, because that's what we're going to get started on, and go to Upload. And please upload those 2 files that I put in that folder, or from the GitHub repo. So just as a warning, I did put this in the channel, but the data files that you put in Azure and that you create in Azure, so the CSVs and everything, those do not persist past this session, right? So if you want to write a whole new CSV file, you're going to want to then download it before you close out. So the notebooks are persisted. You can save those. They will stay with you. But the data that you create will not be persisted. And the Aqua Helper file, it's just a data to this, right? And it'll just, that and the world.json will go into the current directory. So just like on the last set of notebooks from Jonathan, if there's anything, I don't think I'm referring, except for in one place, and I'll point it out, to a different folder. But just make sure you're looking at the current directory rather than somewhere in the GitHub repo that I was kind of pointing towards. So apologies that not all the translation from this to Azure got fully put through. Does that make sense to everyone using Azure? Any questions? Okay. How do you, so I put in the Slack channel, in the Azure channel, there's the Aqua Helper and the world.json. It's also in the GitHub repo, which, of course, I don't have open. The Aqua Helper will be in the scripts file, and the world.json will be in data/aquastat. Okay? All right. So we're going to have a little bit of a change of data set. And we may do some things similarly. We may not do things similarly. And I'm going to let you guys do a little bit of your own stuff as we go. So the data set. I kind of wrote this whole, well, I didn't write it actually. I copy and pasted it from their website. But the Food and Agriculture Organization of the United Nations publishes a data set called the Aquastat data set. And it has a number of data points for each country around water use, water availability, things like percent of population that has access to drinking water, et cetera. As well as some other kind of country markers like population, area, and things like that. And so I thought this data set was interesting first because I did my PhD in water, and then I haven't done anything with it since, so it's kind of nice just to see the word water sometimes. But also, it kind of gives us, it's actually a geospatial panel data set, right? So we have 199 countries over, since the 1950s, 1960s, I'm going to forget now, about, multiple time periods over multiple countries, and then those countries are also geospatially arranged, as we know. And so it kind of will let us have a look at a number of different ways of looking at a lot of different cross-sections of data, if you will. That being said, I will put a note that we're not going to get, there's whole fields of geospatial analysis, there's whole fields of time series analysis. We're only going to kind of start looking at these to kind of understand the data. I'm not going to get into any of the depths of the things that you could do for those. I do have a reference at the end of this notebook for what I've seen as a kind of nice tutorial for some of the geospatial packages for PyCon. But yeah, this will just be some of the basic stuff to kind of get the gears turning and see what we can look at. Okay, so everyone, or it's good to always have kind of a question that you're trying to understand as you're going into a data set. I'm going to choose this question to kind of be thinking about. You can think about this question, or once you get looking at the data, if there's one that comes to your mind that you kind of want to start exploring, feel free to do that too. There's no client asking us, I guess, as I have in everyday life, what the question is. So feel free to do whatever interests you. But maybe for what I'll think about is, let's think about how these kind of water-related metrics, do they have an effect on GDP per capita? So yeah, that's what we're going to be thinking about. So I'll go back to kind of the plan that I had discussed at the beginning of this tutorial. And so in this notebook, we're going to be talking about forming hypotheses and developing investigation themes, and we'll do a little bit of the wrangling of data and kind of figuring out how we can look at it in from different angles. So, develop investigation themes for exploration. So whether you want to kind of address that question that I just brought up, or if you have a question of your own, it would be great if we can go to this, probably the best way is to understand the data, might be to go to this website, and you can kind of see all the variables that we'll see in a few minutes. But start thinking about things that you might find interesting to explore, right? And maybe questions that are coming up in your mind that you might want to go look for. We can either spend a minute on that, or maybe is anything coming to people's mind of things you might want to know from some of these questions or from some of these variables? Yeah. Yeah, so we could go and look for the average rainfall for our country. I think it is, let's see, there is one, precipitation. Yep, so we can kind of go and maybe explore what does the annual precipitation look like for our country, and maybe what does it look like compared to others. Okay? Any other thoughts? Yep. Great, so maybe trying to understand what some of these metrics are, right? So I give you this website because you can get some of the definitions of these things. And so, yeah, maybe understanding, looking at the data and see whether it makes sense for the definition and whether it's going along with how you're understanding it. Yeah, okay, so maybe countries that have a lot more, I guess, flow through them might have higher water use. Okay, that's a really cool investigation theme. I like that a lot. So at this point in EDA, if I'm doing this generally, I'll be writing down these things that I have kind of thoughts and questions that I want to explore, and I'll kind of have those to the side and keep them with me as I go through and do this analysis. And as I answer them, I'll write down notes, but usually as actually just more questions come up, right? And so kind of keeping a tally, or even like a lab notebook, if you will, is a really good thing to do. Okay, so we can think through some of those questions as we're going through this. And let's do a little bit of the early wrangling. So Jonathan talked a lot about making data tidy, and in his case, that was kind of a bit more, maybe less intuitive, I think, than maybe in this case, where we can kind of think of the slices of how we might want to look at this data, okay? So maybe we should look at the data first before we get there. And then other things you want to be thinking about are transforms as well. So if we want to go and let's do the first test and see if everybody can load in their data into their notebook. No, probably because I need to run the first cell. Always important. So if you are in Azure, I hopefully should have changed this to pulling from GitHub. If somebody could confirm that, that would be great. Wonderful. Okay. So what we get is a data set here, and it has for every country, it's got its region, it's got a variable, so total area. So that goes back to kind of these variables here. I've gone and renamed them. I apologize for probably my poor naming conventions. Then it has the variable full, which is actually kind of what relates to what you'll find here in the website. It'll have the time period. It'll also have year measured. So basically, the way that this data set works is it has each of these time periods, so 1958 to 1962, that the data could have been collected in or reported. And so sometimes we might want to just think of the data being from that whole period, but maybe you want to also actually do it to the year exactly. And so it had both of those values available. And so that's what year measured is here. And then the value. So this is basically saying that the total area of Afghanistan between 1958 and 1962 was 65,286,000 hectares, right? So because we have so many dimensions going on, right? Time and country, and then also a number of variables. This is kind of the most effective way of storing the data, but it's probably not really very fun to analyze the data looking like this, depending on what questions we're trying to ask. So what we're going to do first is kind of develop some, and the info just kind of tells you about how many values and what types of values they are. And you can start seeing something about missing data, but we'll see that in a little bit. So this cell will kind of be your reference to be able to go back to and try to understand like what are each of these variables in the future. You can kind of describe the panel and just get an idea of a little bit of the shape of it, and then we can start talking about slicing. So there's 12 different time periods. There's 199 different countries. These are all the different time periods, and I'm just going to calculate this mid-period for later on. And if you have ever done any panel data statistics, we'll say that this data set is unbalanced because we don't have the data reported for every country at every time period. So that's just a thing to think about. And we can do a few checks, and we can kind of quickly see that there's missing data. So that's just kind of a very quick introduction. But for the rest of this analysis, we'll look at the data in different ways. So if we want to look at just a cross-section, we might look at one time period across all the countries. And kind of that's kind of the way that maybe we're used to looking at regular data sets that you might have without kind of the time or the geospatial component. We can also look at time series. So we could look at a single country over time for a different variable. The panel way is looking at all the countries over time. And then we might also want to look at geospatially because we have, they have relationships. You can imagine the weather may be more similar for your country next door rather than across the world. So these will be the ways that we're looking at the data. And so I'm not going to spend too much time on the next functions, but what I've done is just made a number of functions that will help you take different slices of the data throughout the kind of the next few notebooks. So the time slice lets you just give the data in and the period that you want out. And what that will return to you is a data frame that has for every country, the value of every variable in the data for a given time period. And so this is kind of in parallel to the tidy thought, but where your observational unit, I suppose, is a time period. Is that right? Am I speaking correctly there, Jonathan?
An observational unit came in strong. Corresponds to a table.
Yep.
Yep.
So you have, a single variable or a single observation per row. So then we might also want to look at a country and look at them over time. And so the country slice will let you just get the data for a country, and it will show you, so say for Thailand, you can then get the data over each time period for each variable, if you just want to look at Thailand over time. We might also want to look maybe just at a single variable and look at it as panel data, right? So in that case, we can see for every country over each time period what the total population is, and the observational unit there would be actually the variable, I suppose, in this case. And then if we just want the time series for a given country and variable, this is now going to kind of, rather than be over that time period, it's actually going to go and pull the exact year of those measurements. We probably won't use this one very much, but just to kind of show you what that would look like, you can actually get a time series look at this. And then lastly, we're looking at it by region. And so when you have we don't actually have a lot of data points here, 199, it's kind of big data, but it's sometimes nice to look at subsections that maybe you're more familiar with of the data and really get to understand that. And so one way that I might look at through a few of these notebooks is just looking at a single region. So if we look at the regions, there's a lot of regions here, and really they're probably over discretized. And so we might want to kind of simplify the categories into something that makes a little bit more sense for us intuitively, to be able to get more from the data. So usually it's nice to limit your categories to as few as possible, right? We can only keep maybe 7 things in our head at one time. So to be able to actually understand patterns over more than 7 things can actually be quite difficult, right? And we're really trying to rely on our natural pattern recognition during EDA. So here I'm just going to I've basically taken these regions and mapped them to what Chloe defined regions are, which I think we're fairly used to, which are Asia, North America, so I've put Central and North America together, because officially they do go together, South America, Africa, Europe, and Oceania. How do you say I've never had to try Oceania, yeah. I don't think I've said that aloud in a long time. So I'm just going to now remap the original regions to these newer ones. And so now we just have 6 regions, right? And so that kind of will help in a little bit to understand some patterns. And then I have a function here, subregion, which it's nothing too exciting, but if it's easier to think about subregion than doing the pandas, then that's what it is here for. So I am going to put all these functions, as I said, in this Aqua helper so that we'll have them available in the next notebooks without having to kind of repeat everything. And that's kind of generally a good practice for Jupyter notebooks. I would definitely recommend it. I've seen a lot of, myself included, data scientists who will just kind of copy this notebook into the next notebook and delete kind of a lot of stuff in between and then use some of the code. And then you get this kind of morphing piece of code that has this trail, and then maybe you accidentally change something and there's no, anyway, it's the worst thing ever. And then trying to figure out where something happened. So anyway, as you come up with stuff that can be reused, I would always recommend putting it into a script. Jupyter notebooks are great for kind of the development piece and iterating, but it doesn't necessarily lend itself to the right kind of coding practices sometimes. So this might be kind of basics, but maybe think through, make sure you could kind of do each of these exercises. So can you create a data frame containing each variable for every country for the time period of 1963 to 1967? Just kind of make sure you kind of know which functions that I would use there. But as we have limited time, I won't go through those. But now that we've kind of looked at the data a little bit more, if things have kind of, questions have creeped up into your mind, this would be kind of the time to start putting those down again for the next step, when we'll actually get into looking at the data. Any questions on, yes? Do we have any software developers in the room? Because, no, I'm good. Because you're probably right that that's a bad practice. The question was, should you be overriding the original region field with your new region field? I would assume no from a software development. Yeah, so I just kind of simplified the regions into, yeah. Can we get the other mic on, please? Sorry.
So all right, excellent. So I think it's very important to start from, have a clear path to go from raw data to what you ended up with. And I think it's fine to overwrite the same thing in your data frame, because it's as long as you don't write that back out to the raw.csv or wherever you got that from, I think you're safe, especially if you call it like cleaned.csv. So yeah, that'd be my answer.
Yeah, and so you'll see actually that while I take the dictionary and put it into the other file, every time I do pull that raw one in and I do it again, you generally actually will probably want to save a secondary, feature set basically, right, of the data that you end up wanting to use further down the road. And yeah, you would just want to save that as a different file and then just track the code that goes to creating that there, right? So you always, reproducibility is the biggest thing. And so as long as you can have the same input, have the right code, and then get the output, then at least for data scientists, that's okay. No, I think that was a good question. The reason why I did it for sure was because as we're trying to slice all these things, it's hard to keep multiple labels to just the country, basically. Anything else? Yep. What do you mean by? Yep. So do you mean like doing this? So if I do that, then I would just have to preface every function with aquahelper dot. So I could do as AQ, right? And then I could call aq.timeslice, aq.countryslice. And generally that is probably best practice for stuff that is not going to be very obviously different from any other functions you could possibly get. Am I digging myself a hole here? Like yes. Okay, so that's a different question than I was thinking of, which is, right, so if you are updating that file as you're using it in the notebook, there is a magic function for that, which is, I believe it's auto reload. Is it two? How did the auto reload?
Yeah, that's
So just
it is.
one.
I think it's percent load extension space. Load
Oh.
extend. Yeah, it's one word with an underscore. Yeah, that one. Auto reload. I can slack it. I can.
Yeah, and I think
It's a little bit
auto-
tricky to get exactly right because you set it to 1 or 2 and
Let's
you
see.
%A. It's
Maybe you
one
could
word.
find that for me.
Yeah, I'll find out. I'll slack it.
Sorry.
I'm actually
So-
currently, just so people know, people have been asking about these really snazzy little last executed things and
Oh yeah.
in your table of contents deal. So I've been slacking in the
Okay.
general channel how you go in and change that to yourself. So you go to the MB extensions tab. You say, yeah, go ahead and disable the thing. You'll see it there. And then you click on the execute time in table of contents tab. Then you refresh the browser and it'll work. But yeah, I'll get to the auto reload thing and give you an example there.
Thanks. So what the auto reload does, that's a great question, is that it every time it goes to call the function, it will check if any changes to the file has been made, basically, and it'll bring in the function directly from the file. So I think there are a few different options. I think the second option is it'll do it for all the functions. I don't know if you can also, just make it for certain packages that you're working on. And then Azure people, you do not want to append this path because it does not exist for you. But if you have loaded through the data folder or data dropdown, you should just be able to run this line here. Okay? All right, so I can toggle these things again, but then I'll probably lose all my ability to do stuff. All right, so just to show where we are in this process, we're going to look at some quality and profiling of the data. So we'll do some of the initial things. We're not going to cover everything. There's lots of things to look into here. It's kind of a deep data set, even though it's quite small. So here is the wrangling done again. So we'll pull in the data. We'll have the variables for reference. And I'm going to go and apply those simple regions again. Okay, so I've done a little overview here of kind of some of the basic things that I look to do for quality assessment and profiling. So I'll say that in this notebook, we're going to look at all of the data kind of as a whole for at least some missing data and some of the profiling. But as I said, with the whole nonlinear thing is every time then we go into a single variable and kind of look at that in depth, we're going to do a little bit of that profiling along with the exploration as well. So it's not going to just we're going to be done here in this notebook with the quality assessment and the profiling, but we'll do some kind of at least initial components of it. So the stuff that we do during this is going to be pretty basic. We're just going to look at some counting, looking at unique values. Do they make sense? Min and max. We'll do some spot checking and just slicing and dicing and just kind of seeing if it is slicing and dicing the way that we think it's supposed to. And so kind of the high-level questions that we're going to look at is what data isn't there? Is the data that is there right? Is it being generated the way that we think? Obviously, to really understand if the data in this case is being generated the way we think, we're going to have to do a little bit of research with the UN data set, and so we won't get into all the depths of that. But I'll also try to kind of note, for more kind of technology company type data sets, things to be thinking about also that come from this kind of generation question. We're going to use some of the packages that Jonathan used. And then I just put in here this example backlog. So this is kind of a set of tasks or stories, I guess, for projects. If we kind of were to explain the types of things we're going to do for a client during this EDA process, these are just kind of the tasks that we make sure that we're always doing for every data set. So I just wanted to kind of include that there for future reference. Okay, so missing data. So things that we want to think about as we're looking for missing data is, are there actually systematic reasons for the data missing, or is it actually randomly missing? And that can really affect how you handle it for future kind of modeling purposes. Okay, so you want to be thinking through that and looking for patterns in the missing data, such as fields that are always missing at the same time, or maybe if one is there, the other is not. Yeah, and is there information in what data is missing, right? If data is missing for a whole group of people because there was a bug in the system that then didn't let them use the feature that you're trying to understand from your product, that's actually information that you need to be considering, right? Rather than kind of like, get rid of them, they're gone, right? Which is kind of dropping the missing values is always the easy move, but not necessarily the best. So I probably didn't go and I did run these. I'm going to forget to actually run the cells. So for this part of it, I'm going to take one time slice and I'm going to call it the most recent time slice. So we're going to just get a new data frame called recent. And we're going to look back at that bar chart that you guys looked at for previously. And so it's a lot to take in, and hopefully you have it on your own computer because you're not going to be able to read it up here. But it is basically just saying, what in the most recent time period, we're looking at how many countries or what fraction of the countries have each of the variables reported. So what questions does this figure bring up? So I'd like to hear from y'all what you're thinking when you see this figure. And you can kind of, if you can't read the labels, you can tell me, that spot where this is happening. But can anyone interested in letting us know what kind of alarm bells might be going off or things that you definitely want to check out before we went further? Some have a lot more data than others. Yeah, so some variables have a lot more data than others in the database. Okay, so that's a great hypothesis that you'd want to go and investigate, right? Is some of them are empty, so why would they be there? Maybe it's because they stopped tracking them, but they used to be in the data set. Awesome. Maybe one more? Anybody? Okay, we can leave it at that. All right, so if we were doing our analysis at home, we would be writing those things down and making sure that we think about them. Well, yeah, add these to the list of your questions. See? So then what if we look at a matrix? So the matrix now kind of plots whether this data is missing for a given observation. And so before, I think you had to actually sample because you have a lot of observations. But this one, we have just 200, and so we can at least start understanding some patterns here, right? So what more information do we get from this figure than maybe we did the last one that we would maybe want to investigate? Sure. That was what I was asking. So just to walk through what the difference is, right? So the last one was just looking at how many of the countries for each variable had the data complete, right? And so now this is a heat map, and so that means that basically you can kind of see this one line. So that that's kind of the size of one country. And it's going to be black for that country if the data is there, and it's going to be white for the country if the data is missing. And a country is kind of a whole row in this figure. So for example, you can kind of see this white line throughout the entire data set, right? And it also has this kind of little data completeness spike thing, right? And so what that says is that there's one country and it has a little 7 even, that only has 7 fields complete in this data set, right? So what this figure tells you a little bit more is you can start seeing are there actually observations that are having kind of a pattern of missingness, versus if all these white things were just randomly placed, then maybe the data is just randomly missing, right? So now if I do that, I would actually want to go and figure out, well, which country is this line? Which country is this line? Why are we missing? Why is that data missing? What does that mean for when I want to go and analyze it later? What should I be thinking about, right? Anything else that comes to people's minds? All right. So I believe I did look into a few of these, and you're welcome. These are things that you would want to go and check out for yourself as well. I believe there are different offices of the UN that is responsible for a number of countries and reporting on them. They have a whole, so the data set that I originally gave you wasn't actually that pretty. And there was even a little more information on kind of whether the numbers were, I forgot what the different versions were, gotten from another group or if they were interpolated, anyway. So there's definitely more information on the website to answer those questions, but really good things to point out and try to figure out before you're trying to answer any question definitively about the data set. Yep. So one question that comes in my mind, and it came in the last one too, was kind of what are these variables here that are pretty much completely missing or have just a few reported on them, right? So let's take a deep dive. They all have the word exploitable in them somewhere. So first of all, we can kind of go and look at the website, and there's actually a glossary somewhere. That might be better for us to go look at quickly. So let's look at total exploitable water resources. So you guys can read this definition, but it's water resources considered to be available for development, taking into account all these factors. So water available for development. You would think that hopefully all of us have a little bit of water for development, so that doesn't actually answer to me too many more questions. But let's take a little bit of a deeper look into them. So they're missing from most countries. So maybe one question to kind of start sorting things out is, does this happen in each time period? So if we look at we're now looking at a variable slice of the data. So I'm just looking at all the data for the exploitable total, which is the total, the one that we just looked at in the glossary, for each country over time. It's going to give us that data frame, and we're going to do the matrix for that data frame. And I also put in this sorting function here, which basically will just sort by the number of fields missing, just to kind of give us a visualization. So what this is showing us is that there's always been very few countries that have been reporting, but at least still a lot more than we're reporting this year, right? And so the question here, in my mind, is, what's happening? Is, what happened this year? Is it, 2013 to 2017, maybe it's still being reported on and just hasn't gotten to the database? Or maybe most people have just stopped reporting on it because not many people were reporting on it anyway, right? So if you were working for the UN and trying to answer them a question right now, these are questions you'd be asking of them, right? Of kind of what's happening here. Is it something that I should be looking at, or, why has it stopped being reported on? Maybe it's just not an adequate measure, and so we shouldn't be looking at it, right? These are all sorts of questions that you want to answer. And this is also one of those times where you might go for feedback from people that you work with, right? Have friends that are data analysts or something, right, to kind of get their point of view and get them to point out things. And if they have domain knowledge, help you kind of understand the data better to go forward. So, yeah, so one of the options for what's happening is we just don't have the domain knowledge to know what's happening, right? But I am going to drop these variables, but I'm keeping a note of it. So if you're gonna ever keep, just get rid of data, document that decision, and make sure that you're keeping it in mind throughout the rest of the analysis. But because of a lot of the things that we're going to do forward with this recent time frame, turns out if you have only 2 data points for a field, everything has perfect correlation and things like that, right? So you start having kind of some interesting behavior that crops up if you only have 2 data points. So I'm going to now remove the rows that contain exploitable. And again, this is in the wrangling piece, so make sure this is documented in your code manipulation if you ever save out the new data set. Okay? And then one other column that was missing was this national rainfall index. So let's have a look at a deep dive at that one. So I'm going to do that variable slice again. And, so we can see here that it looks like it used to be something that was pretty regularly reported on, but it just kind of stopped being reported on at all back in 2003. So that's good to know, right? So I'm going to take out for our recent, just because for now, for the questions at hand, being able to kind of handle only some of the time periods having this variable and the others not, we might just want to kind of hold off for now in using it. So I'm going to take that out for the rest of the work today. So let's see if there are any patterns by kind of by country. And there's 199 countries, so I might want to look at a subset. So I'm going to look at just North America here. So I'm going to take that subregion, and I am going to plot the bar plots that we are used to looking for, but instead of looking kind of through the variable dimension now, I'm going to look through the country dimension. I put in kind of this nullity sort. You don't have to really worry about it, except for it's just the way that we kind of were able to organize the countries by level of missingness. And so now we're looking at these countries. You can see that some have almost all of their data, and then we have this whole group over here that has kind of, 20% of their data missing, 15 to 20%. So you might want to kind of start figuring out, okay, what might be different in these countries than the other ones? So, I was supposed to ask you that. Is there any pattern in the countries with the most missing data? So, anybody have any hypotheses that you could maybe investigate of like why some countries? Yep. Yes. And so, what are the potential reasons for missing data? I like that one a lot. So we can look at a map here, which in my other window you could actually see the countries that were at hand. But they're all kind of these countries together that are very small, and also islands. So one thing to think about here, we're talking about water resources, is I think there was kind of one variable that was, river inflow from other countries. Well, if you're a country, but you're an island, it might not be able to, it might not be applicable to you, right? That's where some of the domain knowledge comes in to understanding some of the missing data. And then if you're trying to kind of come up with those hypotheses, but maybe it's still not, maybe you don't have a great map in your mind, you can kind of do some spot checks maybe of places that are kind of showing up as missing a lot, that maybe you could potentially have familiarity. You can see, kind of say, okay, which are the variables that are missing for this country? What could be the reasons, right? And just kind of dive a little bit deeper down, especially in things that you might have a better intuition for than others, right? So if I have some idea of Bahamas in my mind, although maybe it's just the beach, but versus, a country I've never heard of before much, then you want to kind of pick things that might get your thoughts going. We don't have huge amounts of time, so I'm going to get you guys to do the fun stuff on the next notebook before. So then, lastly here, maybe we want to look at missing data for kind of geospatially. Are there patterns that are geospatial in the data that is missing? So what we're going to use is Folium. And if you're on Azure, hopefully you have loaded up world.json. And please remove the path to that file. It will just be in the current directory. So remove these folders. And so what Folium lets you do is you can make these, well, you can do a lot of things, but using choropleths, it basically will overlay countries with colors that are corresponding to kind of their data value. And so basically what world.json is it for every country will give the latitude, longitude of the boundaries, and it will allow then Folium to go in and color within those boundaries and put it on the map according to the lat long. So here we are looking at, which one did I plot? Ag to GDP. So this is data reported for the percent of the GDP, I think that's made up by agricultural economic activity. And blue means that the data is not missing. But green, the data is missing. And there's a light color up here for Greenland, and there might be a few light colors other places. Could someone maybe hypothesize as to why we don't have a yes or a no? The country is not in our map, or yes, or yes. Well, correct. So Greenland apparently is part of Denmark? Yeah. There's also a number of other countries that you may see this for, and that is because entity resolution is a thing, and it's a thing that I have not finished out here for you. I can leave that to the reader, and actually I have an article to send you. But we need to be able to match up the country name in the UN database with the country name in the world JSON, right? And so sadly, the UN database didn't give me the JSON, and therefore I made a lot of corrections myself, but some are not made still. And so it's a very interesting component of data and data engineering. But I will leave that up to the audience. So there are a few countries that are missing. Apologies. But other than that, we can kind of now see, are there any patterns in the missing data, say for this agriculture to GDP? And I wouldn't say that I could see any particularly of multiple countries together or something like that. Yep. Okay. Domain knowledge. See how useful it is? Okay, there we go. So maybe when we're in a civil war, we're not going to be reporting on certain things. Very interesting. Thank you. Any other cool tidbits from the audience? I wish we'd actually had time to get people's background. Although I guess maybe if I just knew more about the world. Anything else? Come in people's minds? All right. Oops. So, yep, I've gone and kind of functionalized this this function for future use, and so you can kind of choose different variables to look at. So, if there is a variable that you've been interested in so far, maybe everyone can take a minute to look at the map for a few of the variables that they might want to look at during the next step, where we'll kind of dive deeper into some individual variables. So maybe pick a couple and look into them. Although, let me just finish with the overtime part, where I'm just going to look at a heat map now for looking at missing data over time for the countries for a given, for all the variables. So this is just plotting the number of countries where the data was reported for each time period for the variables. Yep, sorry. Yes, there probably is, but that's kind of the next level Folium user probably. Yeah, there's definitely some tutorials around, and I can try and find it for you, but there's a lot of, actually yes, I know that it is possible. You just have to have the data set to be able to inform it as well. Sorry, the question was whether there is a way to be able to kind of hover on top of the country and say, see the country name, for instance. And so Folium does have some capabilities with that type of thing, or markers and things like that. But I will not get into those today. But definitely, and they're quite useful too. All right, so with that, I'm going to give you guys about 2 minutes to maybe choose a couple of variables that you're interested in that you're going to also then want to look at during the next stage of the tutorial. Okay, and let me know if you have any questions. Yep. Mm-hmm. Okay, so the question was, we've both shown the heat maps showing the missing data, and we've used that to kind of create questions to investigate further. And the question was whether there's a Python package to kind of call out what those exceptions should be that you look at. Not that I know of. I mean, you kind of have to, you almost have to build in some of that logic, right? And it's not necessarily logic that repeats necessarily. Not that I've seen, no. But you could make it. I'm sure people would like it. So I have some extra content in the next few notebooks that kind of aim at trying to automate a little bit of what to hone in on. I haven't seen anything great so far, but there's also a big world of Python packages out there. But there is some stuff that I'll go through, because you might get to data sets where you have hundreds of fields, and you can't go and look at each one, right, every time. So yeah, but I don't address that as much in this one. But you can imagine kind of putting in checks of, when a row hits, more than 80% of missing, it will ping, right? And there are some filters from that package that you can actually put cutoffs, and it will just give you, say, the countries or the observations that are past the cutoff on missing, right? So it'll do some of that for you. Yep. 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 Sort of. So usually you're applying a function, right? So you're aggregating. So you're actually making a choice to take away some information, is what I would be calling out as the biggest piece of that. Unstack is, I'm going to get confused between pivot and unstack. There are slight differences, but it is about just kind of how your data is structured right now and how you want it to, right? And kind of changing rows to columns, etc. So sometimes it's whatever you remember and can make use for yourself, right? So I have more experience in unstack and stack than I do in the pivoting. But the ag is definitely different, I would call it. Yep. All right. Did I just hear something? Okay. So as I kind of said earlier, as we go into each variable by itself, we'll probably continue to do some profiling and even some of the quality measurements, but it can be nice just to get, what Jonathan showed earlier is a whole kind of holistic profiling view and kind of see everything at the same time and get some, start getting some observations together. But in profiling, you really want to kind of do all these different ways of looking at the data. And here are some kind of the questions to consider. So are there frequent values that are default values? So if there's an, -1 is an example, sometimes will be what was used as missing or default. And so if you have a continuous variable, but just an extreme number of people have this weird number, right, you're going to want to go and investigate that. Are there fields that represent the same information? I've seen a lot of databases where you have like the time and the current area, as well as UTC or all the different places, right? And you don't really need to look at each of those timestamps. Are there numerical values that are reported as strings? Special values, again, kind of like the -1. Are there values that are put in there for special reasons? Are there numerical numbers that should actually be categorical? So if you have just 0, 1, 2, and 3, and those are the only values in the whole variable, you might want to actually change those and look at them as categories. Is data consistent across different operating systems, device types, platforms, in this case countries? So this is not as applicable here, but for example, I did a lot of work on an app that was in both Android and iOS, and the I don't know what clickstream. I never know what the name for it. The interactions were reported in very different ways for Android and for iOS. So they were called different things. Not all of the same ones were reported, but they were all in the same database, right? But they actually described completely different parts of the user's behavior, right? So you really want to understand, especially for like tech stuff, right? Different platforms, different releases of an app, things like that. You really want to make sure that the data is consistent across those, or if you actually need to actually separate them out and analyze them separately. Are there any direct relationships between fields? So if something is always, if two fields always have the same values together, you want to think about that and what to do with that. Do you need both of those fields? Understanding units of measurement, making sure that they're reported on the same across different observations. Is the data consistent across the population and time? So a lot of cases, maybe over time, the ability to actually measure water quality has improved so much that the data today is going to be very different than the data 40 years ago. Should you be able to actually compare those values and start making observations based on them? Are there obvious changes in the reported data around the time of important events that affect the generation of that data? So kind of going back to version releases, you might see kind of a complete change in your metrics, right? And then be like, oh, that's actually because we rolled out a whole new version of this, the software. So of course things are going to change, right? You don't want to necessarily analyze that together with the old stuff. You might want to compare it, right? But you want to be very cognizant that you're comparing it. So I apologize to Azure people. This will not work, I don't think. It's the pivot table that Jonathan showed. This is somewhat useful for this to see some missing values and things like that. It's actually not great for just numerical data, but you can do some kind of playing around and see some things. And then the pandas profiling. Yep.
pivot table, I didn't actually get to show that.
Oh.
I actually have it loaded so I can show it. But if you want to just show what it means to drag things around, maybe I have to zoom out a little bit just because.
Let me pop out. So, do you want to? You're more well versed in this.
Sure.
But basically,
So-
you can.
Yeah, you can drag any of the columns of a data frame into either of the workspaces. And if you have one column on one side, say country, versus say GDP or some other column, and put it over there, it will do a cross pivot table of the two things. And you can do further aggregations on top of that. Like you can have, let's say, be a thing that makes sense.
I'm trying to see what makes sense actually.
So you could do, let's do GDP and then total, yeah, so let's do GDP in the top one. And then instead of count, change that to, let's say, average. And then select, when it comes up with something, the population. So there's another drop-down menu that just appeared, yeah.
Like the pop. Oh.
Yeah, and now, let's see, does it have, is there any values anywhere on this?
Well, because everybody's going to have a different GDP.
Huh?
Everyone's going to have a different GDP, so you're going to get the.
Oh, you're right.
Sorry, it doesn't work out that well. Oh, maybe, you know what? Seasonal variability.
Yeah, you can also do it in the same one, and it does a double cross tab. Okay, so now let's do, yeah, you can do like the average of this one, or total population. Instead of, if you scroll all the way to the left, other left.
Oh.
Do instead of table, all the way there, do a heat map. And in theory, that should have colored things. Yeah, so now it has outlying values. So when you have like a whole table of things, it's very easy to, by eye, check out like, hey, this is an outlier, and that kind of thing.
This is really good for categorical by
Yeah, I have an
categorical.
example I can
Yeah.
switch to. If you have a few minutes at the end, I can show a better example.
Probably not, because it's
Okay.
still 12.
Yeah, no, I understand.
Sorry.
Anyway, pivot table is very cool. It lets you very quickly just get a visual sense of these kinds of things. You just click and drag.
So I'm going to jump now. Anyway, this is the profiling that Jonathan went through earlier. It's good just to get an idea as a whole, but we'll want to look at each variable individually and really explore deep into some of the ones that are of interest. So I'm going to go through kind of the exploration of population, and then we're going to be out of time soon, but it will leave you the ability to go and do it on your own. And then the next two notebooks also have content in them as well. Apologies for the timing. So again, we're bringing in our past functions. We're on now exploring each individual variable in the data set, and this is going to be kind of a place where we're going to get a lot of those branch off points of kind of questions we might want to go and explore. So let's wrangle the data. And so things that we want to look at for a cross-section, so we're going to look at that recent time slice again, as kind of for a given variable, its location. So, you know, its mean, median, mode, where kind of does it lie? What kind of values does it lie in? How much is it spread? Are all the countries kind of very close to that mean, or is there a lot of variance? And then also shape, so skewness and kurtosis, which we'll talk about briefly. But whether or not, really one of the biggest things to think about there is whether or not it's normal or bell-shaped, right? Because that can affect a lot of modeling later on. So the first thing to really think about is, let's look at the kind of the range and the location of this data. Are the minimum, maximum values feasible? This is a really good first question to always think about in continuous. And can somebody point out here maybe something that could be suspect for this population? Oh, -98. I think maybe 1,000 people. Huh. That seems kind of weird. I don't know why they don't get to be counted. So this is definitely something that's going to, again, be also quality. It's still kind of in the quality realm. If we look at kind of the people or the places that's happening, we can see it's in a few places. We might go to the glossary, and we'll see that the rural population is actually just calculated from the total population and the urban population. So somebody didn't actually go in and write at the end of the time period versus the total. So things to go and investigate. We can go and look at, say, Qatar, am I saying that right? Over time and see if it was always a problem. Nope, they started just going into the negative in the time period before. So what do you want to do about those non-physical numbers? Should you remove them? Should you replace them with other estimates from other sources? Whatever you decide to do, it just needs to be well documented. It needs to be told to whoever is going to then use your results based on it. So just always kind of have a trace of when the decisions are made and how. So then, start thinking about the shape of the data. We can start getting an idea that maybe there's some skew or some non-normality. If we start kind of looking at, if we compare the median, and if it's much closer to either the 25% or 75% style, we might start getting an idea that maybe our distribution is skewed. So some measures of looking at that are skewness, which measures lack of symmetry. So if we want the normal curve, it should be, symmetric, and the skew should be close to 0. It's 9, so that doesn't sound great. There's also tests to see if this is statistically significant, but we won't get there today. Kurtosis then looks at whether we have kind of heavy tails, so are there a lot of outliers? And this we've got up to 95, so that also is supposed to be 0. But really, the easiest way to look at this, right, is our trusty histogram. And yeah, probably doesn't look like a normal distribution here. So why is this a problem? So one I kind of mentioned earlier is that if you're using something such as a linear regression, right, what that actually depends on, technically, at its core, is your data being normally distributed. It's not valid otherwise, right? So that's important. But in other ways, it's also, if you looked up here and you knew all the countries, can you really differentiate between the countries? Can you start making any patterns like, oh yeah, these 50 countries versus these 50 countries, they all look the same, right? When you have them all kind of lumped in the same box. And so, we can look at that by looking at a map, which is kind of the same function that I showed you earlier, but now we've got kind of shaded based on population. And great, we see that, India and China, they have got a lot of people, okay? US, they've got a lot of people. They're also kind of bigger. Everywhere else, the same. That doesn't really tell us much, right? So often doing a transform can be useful in sort of pulling out and differentiating your observations. And so often if you have a heavily skewed like that, you can try a log transform. So that's just applying the log to each number. So we can kind of look at if that changes the skew. Okay, it kind of actually puts it back in the other direction of symmetry, but it reduces the kurtosis a lot. So let's look at the histogram, which we've then functionalized. Okay, so this is looking more normal, right? I don't know if it would actually cut it for our modeling, but for actually being able to start looking at patterns between countries, it's really separating out, at least, those countries so we can look at maybe what differentiates them. And if we look at the map here, okay, we can start seeing a few more things, right? We can start looking at understanding differences between those countries. Okay, so the other thing is, if we're thinking about how water availability and water use affects a country's, GDP, you might also want to understand, a very small country might not have much water if the population is still very large, right? So it actually matters how many people are in that country versus how much water that country is getting, which is kind of a function of the area and population. So another thing you might want to do is normalization, right, is what's the population density in that country. So if we think about it, if you've got a ton of people in a very small space with the same amount of water as not as many people, that's actually going to make a difference based on the area that they're living in, right? So normalization is always a really important thing, and it's just division, but it's one of the most important tools, I think, in a data scientist's toolbox. And so that will actually also start differentiating countries, and that might have maybe more relation, let's say, to the effects of water availability and water use as a hypothesis. Okay, and then lastly, we can look at over time the population. And so I'm going to start off here just looking at the US, get an understanding of, it's a country maybe I'm familiar with. Do I understand what's happening here? So picking kind of a sample to make sure and get your grounds to whether you understand it. Okay, 320,000. I think the US is a little bit bigger than that. This is just kind of the thing that you have an intuition for, so you know the units must be different, right? Versus if I, checked a country that I really wasn't as aware of, I might not be able to pick out those things as easily. So then maybe we want to kind of build up to one region and look at their values over time, which, all right, this isn't very helpful, right? All these countries in North America, we just saw it. We saw some really tiny islands. Obviously, they're going to have much lower population. And besides being a terrible graph for many lines, we're also not going to really understand change over time if we're looking at them all on the same scale. So one way to get a better look is, again, to normalize. And we can normalize by a lot of things, but let's say if we normalize by the population of each country in their first time period, we can kind of see how much each one has grown over time. Okay, so this kind of brings the countries together. They're color-coded. I think the green are the smallest population countries, versus purple were the biggest ones. We can start seeing some patterns because of these colors, but again, if you have more than 3 or 4 lines on a graph, you're not going to get much out of it. So we could do the same, but maybe look at a heat map. Bless you. And then you can start actually, it is a lot of information, but if you're really trying to dig deeply into it, this isn't a graph that you'd want to, show in a presentation, but if it's for you, using it for EDA, right, you can start pointing out the countries that have grown much more quickly than other ones, relatively, and start really gathering information from this kind of graph. And then lastly, as we have only 2 more minutes, I will give a quick widget demonstration, right? So if we want to look at over time the change on that map, we can use a widget, which basically you can define, you want to, say you have a function, and one of those variables you want to be able to change and kind of see how the function's output changes with that change in variable. You can define it as a widget and input it into that function. And so if we take our map plotting and now make that time period that we were inputting into it a widget, right, we can start looking at changes over time. And so we have this little slider up here, and we can kind of, start assessing changes. You can also see, there's more white up here, which means we have the matches aren't working, right? So if you can imagine what's changed in maybe, say, Russia, maybe its name has changed, things like that, right? And we'll start actually, only in this view will you kind of maybe get some more quality understanding as you go. So with that, it's 12:20. You were supposed to do so much of this also as an exercise while we were in this, but you can now go and do that on your own. And we encourage you to do so, and we'll have the Slack channel still going. So if you guys want to kind of go and try out what we've gone over here today, maybe share things that you've figured out by yourself, please use the Slack channel to do so. Maybe we'll think of some channels that would be good for maybe both data sets.
I also, there's a good question that I want to answer, or at least address in the channel when it's asked. Is there a place where you track the assumptions, justifications, and changes that you're making along the way, somewhere besides either pen and paper or a notebook somewhere? How do you do that? And I'll answer for myself first, and you can answer if you have a different one. But I think having an end-to-end from raw to cleaned or from raw to final version workflow with the justification being plots, for example, saying like, this is why I'm choosing this now, making a choice here, is the best thing I have as an idea for that. So that's what I currently use. I don't have a better answer than that. So if someone else has a better idea than that, I would like to actually hear it. I don't know. Do you have what are your thoughts on that, Chloe?
Yeah, I mean, I think I generally use the notebooks because of the ability to write as you go and comment on every figure. That is kind of the record that's the record, right? When I say write everything down, it's hard to go back through those notebooks really in a useful and efficient manner, right? So it's also nice to have on the side somewhere that you're writing these things down. But yeah, as you go in the notebook, everything should be documented so that if you do have to go back, you can. Cool. Other than that, as you start to pull out the reusable pieces of code or things that you're going to maybe use later in maybe production, let's say, you can, in a script, actually document as well each of those choices that actually were choices that end up being kind of permanent. I would definitely put it in there as well. Yep. Kind of depends on what type of documentation you're doing. Anybody else have good ideas? I like to hear everyone's ideas. Yep.
What was the question?
Oh, the question was, do we use version control much? And I find yes for. I think the thing that where that is, when you're just doing development work for like EDA and data, right? Notebooks are kind of hard to do diffs of and kind of see, and you're not going to want to document every change in code during the development process versus, yes, if we're going to change code that's actually being deployed, for sure is going to go into,
There's a tool
release notes.
That's in alpha release now called NBDime, which lets you do diffs of notebooks in a nice way for version control. NBDime, like notebook dime, like a nickel dime quarter. And so it allows you to do diffs on GitHub, or git commit diffs as well. And it'll even do things. So the key thing with like software engineering is like you want to usually version the code itself, not the output. But if you actually want to review the output of someone else's analysis, or if you want to review someone else's analysis, you actually look at the output. You actually look at the plots and the graphs and the figures to kind of assess that quality. So when you're doing that kind of peer review for that, the output actually matters, and in my opinion should be committed, even though this makes software engineers cringe a bit. So it's just that, as Chloe said, the diffs are hard, and they're getting easier with these tools like NBDime. So
yep.
I think we're actually out of time.
Yep.
So
also,
I'll just say thanks a lot from me at least. It was a lot of fun. Hopefully you learned a lot.
Thank you. Please take us up on Slack. And somebody asked if those would be persisted.
Yes.
There's up until 10,000 messages have been written. It will, at that point,
it starts chopping off the tail.
Yeah. The oldest messages will start being lost. But that's still a lot of messages. So we've got some time. But yeah, the Slack group will not
as much as possible.
disappear.
Python 3.
Basically, it will be there.
But